Welcome to my channel. Today I have a video on the hardest SAT math with calculator multiple choice questions from SAT practice tests 1 through 9, as well as the main SAT from 2018 released by the College Board and the main 2019 SAT also released by the College Board. So as I go through these videos, I'm going to try to give you an inside look at what I see on the SAT math with calculator section for these harder questions as someone who scored perfectly on the SAT math section on back-to-back SATs. So I'll try to break things down by giving you strategies, tips, tricks, and advice, as well as answer explanations for each question. So as I go through, I'll start by going through with slowed down and in-depth answer explanations taken from my 90-day SAT prep series. We're going to go from SAT practice test 1 to SAT practice test 3, then 4, then 2, then the main 2018 SAT, then the main 2019 SAT, and then after that I'm going to go into some faster paced answer explanations for these harder problems from SAT practice test 5, 6, 7, 8, and 9. So there will be no content from SAT practice test 10 in this one. So with that, let's go ahead and get started. Make sure to like, share, and subscribe if you're looking for more SAT prep material. I also have a 90-day SAT prep series and a 14-day SAT prep series available on my channel for free under the playlist section. So be sure to check that out, and let's go ahead and get started. All right, so with that, let's go ahead and get started with question 24. So which of the following is an equation of a circle in the xy plane with center 0, 4 and a radius with endpoint 4 over 3 and 5? All right, well, we got to know our circle equation in order to get this correct. So we know our circle equation is x minus h squared plus y minus k squared equals r squared, where r is our radius, okay? So that's going to equal our radius squared. Now, we know that in this situation, our center is hk, right? So if our center is 0, 4, then we just plug those in for h and k. So we have 0, 4. So x minus 0 squared is just going to give us x squared. And then we'll have x squared plus y minus 4 squared. Y minus 4 squared. So at that point we can get rid of b and we can get rid of d because they have y plus 4 and we need y minus 4 squared. So the next thing, our only difference between a and c is our radius squared term. So let's go ahead and find that. Well, we see that we have our center and we have our end point of a radius. So if we want to solve for that, then we can use, I'll go ahead and plot this out so you can see it better. All right, I'll do an example circle. So this is going to be 0.04. So I'll go 0, 4. And I'm going to zoom in so you can actually see this much better. Let's zoom in, and then I'll erase this real quick, and I'll rewrite it because I want you to be able to see this. So we're going to have 0.0, okay, that's 0 and 4, okay? So that's what that point right there is. Okay, now it tells us that our end point of our radius is 4/3 and 5, right? So we know 5 will be 1 above that 4, so this will be our 5, right? And we know that that's at 4/3, okay? So we go over and up to form this little triangle here. And we see that the radius then is the hypotenuse of this triangle. So we know that we have that 5 minus 4 means that this side is going to be a 1, right? That side length is going to be a 1. And we know that we go from 0 to 4/3. So this side length is going to be a 4/3. So now in order to solve for this hypotenuse, which is going to be our radius, right? That's our radius. We have to square that 1, so 1 squared, then add 4 over 3 squared, and that's going to give us our radius squared. Now keep in mind, we don't actually have to solve for our radius. We only need our radius squared because if we look up here, we see that that's what we have in our circle equation, right? R squared right there. So all we got to do is solve for this now. We do 1 squared, which is just a 1, and then we add 4 over 3 squared. So when we're doing 4 over 3 squared, what we're going to do is we're going to square 4. 4 times 4 gives us 16, and then we do that over 3 squared. 3 squared is 9, so we're going to have 16 over 9. So now in order to add them, what I'm going to do is I'm going to switch this 1 to a 9 over 9 to make it easier to add. So now I do that, and I see my answer is going to be 25 over 9. Okay, so that's what r squared will equal. So now I just find which answer has that, and I see that answer choice A has that. So A will be my correct answer for 24. So as far as tips that you can use there, if you're stuck on a circle problem and you need to solve for the radius, one thing I recommend doing is drawing out the circle. That way you can kind of see visually what you're going to need to solve for, right? So you got to take that that 1 there, that difference there, that 4/3. You got to square each of them and add them in order to get r squared. So when in doubt with any question on geometry, triangles, shapes, circles, go ahead and draw it out. That can help you see visually what the correct answer is going to be and how you can get there. Okay, the other thing that was really important here is just memorizing the circle equation. Okay, I highly recommend that you memorize it. I think that it's very, very important too. So definitely make sure that you do that. And then other than that, that's really it. After that was just understanding that you have to solve the hypotenuse of that triangle that forms right there. All right, question 25. Alright, the equation above expresses the approximate height in meters of a ball t seconds after it is launched vertically upward from the ground with an initial velocity of 25 meters per second. After approximately how many seconds will the ball hit the ground? Alright, so we got to solve for when the ball is going to hit the ground. We know that that's the height h, so when it hits the ground, that height's going to be 0. Okay, so if we're solving for the zeros then of this equation, immediately what I see I can do is I can factor t out. Okay, so I'll factor t out, so I'll have t then times negative 4.9 t plus 25. Okay, and that's got to equal 0. Okay, so t equals 0 is an option, but we know that that isn't an option because this ball is launched vertically, so it's going to have to be in the air for some amount of time. So we know that t equals 0 will not be our correct answer, and then we'll have negative 4.9t plus 25 equals 0. We'll add 4.9t to each side. That way we can get a positive coefficient, right? We add that. That's going to cancel out. So we're going to get 0 there. We add 4.9t to this side, 4.9t. We're going to have 25 equals 4.9t. We divide each side by 4.9. Divide each side by 4.9. 4.9 over 4.9. Okay, and we see that t is going to equal 25 over 4.9, which we know is going to be about 5. So our answer there is going to be D, because that's going to be approximately 5, right? So I'll do my approximately sign for that equal sign. It's going to be approximately 5. So answer there is going to be D for number 25. So as far as what we can take from this that you can put in your notes to make sure that you're really understanding how to solve these more difficult problems, a big thing here is just understanding that if our ball is going to hit the ground, that means our height's going to have to be 0. Okay, so there's going to be times when you're going to have to substitute something in like that, and it won't be stated as a number. Okay, it'll just be stated in a statement, and you'll have to be able to figure out that when it hits the ground, that means its height is at 0. Okay, so understand that if you're missing a number and you need a number to solve something, look back in the text because it's probably given somewhere. It might not be given as a number, but it might be told to you in another form. For example, the ball hitting the ground tells us that the height has to be 0. So always make sure to watch for that. If you get stuck and you feel like you're missing a variable, go back in the text and see if you can find it somewhere. It won't always be stated explicitly, but it could be stated implicitly by saying that that ball hits the ground, which means height has to be 0. And then the next thing was just factoring out that t. So we factored out the t, and then we set this part here equal to that 0. All right, so that takes us through 25. Now we can go ahead and switch over to question 26. All right, so Katerina is a botanist studying the production of pears by 2 types of pear trees. She noticed that the type A trees produce 20% more pears than type B, so that means type A is going to equal 1.2 times whatever type B produces. Based on Katerina's observation, if type A produces 144 pears, how many pears did the type B trees produce? Okay, well, we already know that we had that equation because we already put it down as we read through, which is something I recommend doing as you read through any long word problem that's about 4 lines or more. We always want to make sure that we are writing down any equations that it's telling us as we read. So we read that type A trees produce 20% more than type B. So that means we're going to do 1.2 times whatever the type B produces, and that'll give us that type A since type A produces 20% more. We know type A produced 144, so we set that equal to that 1.2b, and we solve for how many type B trees produced. So we divide each side by 1.2 to isolate B. 144 over 1.2 is going to give us 120, which means that our type B trees are going to produce 120 pairs. So the answer there is going to be B. All right, so as far as things that you could put in your notes here, one thing I said, and I said that already, is just to write down your equation as you go through. And then if you did that, this problem really becomes really easy because you just substitute in that 144 for A, and then you just solve for B. So this one really is not too difficult at all. For it to be 26 on the SAT math with calculator section is a little bit surprising just because of the simplicity of the problem right there. So that one really should be a give me, and you should be excited to see that this late because that one, you could definitely get a much harder problem this late in the math section. So that was definitely a bit easier. All right, 27. A square field measures 10 meters by 10 meters. 10 students mark off a randomly selected region of the field. Each region is a square and has side length of 1 meter. No 2 regions overlap. The students count the earthworms contained in the soil to a depth of 5 meters beneath the ground's surface in each region. The results are shown in the table below. Which of the following is a reasonable approximation for the number of earthworms to a depth of 5 centimeters beneath the ground's surface in the entire field? All right, well, we need to know how big our entire field is. We know it was 10 meters by 10 meters. 10 meters times 10 meters gives me 100 meters squared, or 100 square meters. The next thing I know is that each student is marking off a square region with side lengths 1 meter. So that means that they're each marking off 1 meter squared. Okay, and then they're counting the number of earthworms and a depth to 5 meters. And we know that we're asked about the entire field being to a depth of 5 meters, so that 5 meters there is going to cancel basically. So now we're going to have the number of earthworms in these regions. Okay, I see that I have in my answer choices differences of factors of 10, so I don't really have to worry about being too accurate in counting my average right here between all of these regions because that's wasting time. I see it's about 150 and I see all my answer choices are multiples of 150, so that's what I take it as. Okay, so I take it as 150 per each meter squared. So 150 earthworms, I'll put earthworms as E per meter squared. Now we have to multiply that by that 100 meter squares in our whole field. Okay, so we have to multiply that by 100 meters squared because that's how big our field is. We see our meters squared term is going to cancel and we'll be left with 15,000. 15,000. So our answer there is going to be C, 15,000. All right, so as far as things to put in your notes there, really the big thing is understanding that if we have dimensions like 10 meters by 10 meters, understanding to multiply them to get our total area of the field. After that, understanding that each region is square. So notice how as I read through a word problem, I annotate the text, right? I'm underlining and circling and squaring things. So any measurements I get, I want to pay attention to. Any restrictions, such as no two regions overlapping, I want to pay attention to. Anything with shapes, I want to pay attention to, such as each region is square. Anything with depth, that's also a measurement, want to pay attention to that. Anything like that, right? And then as far as another big thing here is understanding that we don't have to calculate the exact average from A through J, right? We can just kind of get a rough estimate. And how do we know we can just get a rough estimate? Well, we know we can just get a rough estimate because all of these have that same beginning, right? They're all factors, or they're all 15 multiplied by some 10, right? Whether that's 10, 100, 1,000, 10,000, anything like that, right? So we knew we didn't have to calculate that average. That would have just wasted time. Right, so understanding that we can use our answer choices on the multiple choice section to guide a little bit of our work. All right, so now we've got question 28, I believe. Let's see what just happened. It looks like I zoomed way out a minute. Let me get back to where I was. Got question 28, I believe is what we are on. Yep, all right, let's get started with question 28 then. So I see I have 4 quadrants. I'm told I'm dealing with a system of inequalities. I've got y must be greater than 2x plus 1. I can go ahead and plot that. This plus 1 means that I'm going to have 1 as my y-intercept. I'm increasing by 2x, so that's a positive slope. So my line would be something like that. And I see it has to be greater than, so y's got to be greater than that, so I can shade in that side. Then I have y must be greater than a half x minus 1, so that minus 1 would be right here. We're also increasing still by less than that slope of 2x, but we're still increasing. I see y has to be greater than that as well. So I can shade in that as well. Now I'm asked in which quadrant is there no solutions to the system? Okay, well there's going to be no solutions to the system where both aren't shaded in. Okay, so we know that we would only shade in for, oops. Okay, I'll go ahead and rewrite this. So we know that y's got to be greater. We'll call this one, I'm going to call this equation 1, and I'll call this equation 2 just so I can label their lines so you can see it better. That's a 1, that's a 2. We know y's got to be greater than 1, so its solutions are going to be the shaded regions here. Okay, now for 2, its shaded regions would be everything above here, but since we need it where they both are satisfied, we can't include that, right? We would only shade right here. Okay, so the only region that's going to be shaded is going to be this right here. We see that that goes into quadrant 1 because it goes into this quadrant 1, goes into this quadrant 2, and it goes into this quadrant 3, but we see that it does not go in quadrant 4. So the correct answer for the quadrant that contains no solutions is going to be C, quadrant 4, because they don't both satisfy at any point in quadrant 4. Right, the only one that satisfies quadrant 4 is equation 2, but equation 1 does not, so therefore quadrant 4 does not contain a solution. All right, so we got C for 28. As far as big things there that you could put in your notes or watch out for, anytime we're dealing with something like this, we got to really pay attention to the fact that if we want a solution to be in quadrant 4 right here, we would have to have this line 1 be something like this, right? If line 1 were like that, then we see that we would have quadrant 4 would work. But since that line never comes in quadrant 4, that does not work. All right, so with that, let's go ahead and switch over to question 29. So we've got a polynomial px the value of P3 is -2, which the following must be true about Px. Okay, so anytime that I see a question that's worded like this with a polynomial and the value of P of a number and then just being given what it is, so in this case it's -2, I'd be looking at two things. So one, if it is 0, right, if P of 3 is 0, well that means that it's an x-intercept, which means it'd be a root. So in that case, I'd be looking for x minus 3 to be a factor, right? Since this is P of 3, I'd be looking at x minus 3 to be a factor, because then we'd have x equals 3, right? So I'd be looking at x minus 3 to be a factor in that case. If it were equal to 0, we know that it is not equal to 0, right? We know that it's equal to -2. So we can't say that it is a factor, right? We can't say anything is a factor based on that. But what we can say is that the remainder when P of x is divided by x minus 3 is -2, right? So this P of 3 means that I'm taking this x minus 3 and I'm dividing P of x by that x minus 3, and then whatever this right here is, that's going to be my remainder, okay? So if that remainder is 0, then we know that it's a factor, right? So if it was to say is 0, then we know that it's a factor. In this case, it doesn't equal 0, so it's not a factor. We can't say it is a factor. But what we can say is that the remainder is going to be -2 when P of x is divided by that x minus 3. So we take whatever's in here, right, in that P of whatever, we flip its sign, right? So now we have x minus 3 because we flip the sign. And we know that when P of x is divided by that, then our answer there is going to, or our remainder is going to be -2. So that is one thing you could put in your notes. So if I was going to put this in my notes, I'd basically put down, I'd try to just give an example, I'd say. So I'd probably put down P of 3 is -2, and then say the remainder when P of x is divided by x minus 3 is -2. And then I'd probably also put an example of, say, if P was 5 is 0, then P minus 5 is a factor of P of x. Okay, so I'd also give that example. That way you know what it is when it's a factor as well. All right, so now with that, let's go ahead and switch over to question 30. So this is our last question. So this one's usually going to be the most difficult on the SAT math with calculator section, in my opinion. It'll usually be 30 or 38. But in my opinion, it'd usually be 30. All right, so which of the following is an equivalent form of the equation of the graph shown in the xy plane, from which the coordinates of vertex A can be identified as constants in the equation? All right, so this is a big thing you need to understand. Anytime that you're told that you need to have something identified as a constant in the equation or as a coefficient in the equation, that means that it has to be that number, it has to be present in that equation, right? So in this case, we need the coordinates of vertex A to be present in the equation. So let's go ahead and find the coordinates of vertex A. We see that that's at 1, right? Go down here, your vertex is going to be your lowest or your highest point. If it opens up, then it's going to be your lowest point, and if it opens down, it'd be your highest point. In this case, it's going to be our lowest point since our graph opens up. So that's going to be at 1, and then at about -16. Okay, so we're looking for the coordinates to be identified as constants. We see that the only one that has them identified as constant is option D. So right there, option D is going to be our correct answer, right? So 30 in this case is actually a really, really easy one. SAT practice tests 1 through 4. I find that they're a little bit more out of order than 5 through 10 are as far as difficulty of questions. I find that practice tests 5 through 10, their difficulty is much more, it does a better job of getting more difficult over time. So questions 1 through 30, it gets progressively more difficult. There aren't many easy questions at the end, in my opinion. Keep in mind that is in my opinion. I'm not someone who is associated with the College Board or anything. That's just my opinion as someone who's taken a lot of practice tests and scored 1590, 800 back to back. But yeah, so really we're just looking for the coordinates of vertex A to be identified as constants in the equation. The only one that has those coordinates identified as constants is D. It won't always be like that. Sometimes it'll have, you'd have constants that are identified as this with another option, like example could be A, and it'll have -1 and -16, or 1 and 16 as an answer choice, right? But then at that point, what you'd have to do then to find your answer is find which one actually is equivalent to this equation here, right? So if you did have two options that both have those constants, then you have to actually figure out which one is equivalent. But in this case, since we only have one option that has those constants, we automatically knew the answer was D. So that's something you can put in your notes as well. Mr. Cole has a beaker containing n milliliters of solution to distribute to the students in his chemistry class. If he gives each student 3 milliliters of solution, he will have 5 milliliters left over. In order to give each student 4 milliliters of solution, he will need an additional 21 milliliters. How many students are in the class? All right, well, it's going to be, okay, so we're going to set these two equations equal to each other. So how did I get these equations? Well, the first thing that I think you should put in your notes, if you're taking notes on this, is that as I read through this, I went ahead and I wrote my equation down, okay? So what I was writing down is anything that I saw as a relationship between variables. So I saw that we have, if he's giving each student 3 milliliters of solution, then 3 times his number of students, right? This is an S here, not a 5. Okay, that's an S, not a 5. 3 times his number of students, since he's giving 3 milliliters to each student, plus that 5 he's going to have left over is going to give him his total number of milliliters for that expression there. Then I saw that in order to give each student 4 milliliters of solution, so 4 times each student, he's going to need another 21. So the amount he has is 4s minus that 21 that he needs. Okay, so I set those two equal to each other since they're both going to be that total number of milliliters he has. And then I go ahead and solve then for my number of students, which I represented as s. Okay. Now, why did I pick S as my variable to represent students? Well, that's because it's the first letter in students. Okay, so one thing that you should get into the habit of doing is anytime you're given a variable like I was up here, in this case it was students, I saw it up here, I'm going to use that first letter of whatever that is. If it was workers, I'd use W. If it was teachers, I'd use T. If it was time, I'd use T. Anything like that, I'm going to use that first letter of whatever it is as my variable. I'm not going to pick X. And the reason why is because as you get into other problems, some of them will tell you they'll have A, B, C, D here, and they're going to have something such as 10S plus 80 W or something like that. And what those S and those W's will be is they'll end up being the first letter of whatever variable they represent. And that's really a commonality that you generally see on the SAT math section. It may not always happen, but in my opinion, I've really seen it happen most of the time. So that's what I would highly recommend you doing, because that's going to make it easier for you to match equations on other questions. So that's just a good habit to have. That's something you can put in your notes. All right, so back to solving for this problem after I gave you that topic or that hint to put in your notes. So in this case, we have our equation set up, right? Now we're just going to go ahead and solve for s. So what I'm going to do is I'm going to subtract 3s from each side. Why do I do that? Why did I pick to subtract 3s and not 4s? Well, I did that because I want to solve for s, and by subtracting that 3s, I'm keeping s positive, right? And I'm solving for s right away. I don't have negative s, I just have s. Okay, next I'm going to add 21 to each side because I have to set s equal to a constant. So 21 plus 5 is going to give me 26. I see s equals 26. I know s represents my number of students, so my number of students then will be D26 for question 24. All right, now we got question 25. Okay, so I've got a cubic silo. Okay, let me zoom out a little bit so you can see the whole thing. All right, so we've got this silo here. Okay, so we've got a grain silo is built from two right circular cones and a right circular cylinder with internal measurements represented in the figure above of the following, which is close to the volume of the grain silo in cubic feet. Okay, so one thing I want to talk about here. Okay, we know that we have to know the volume equation then for this cone here as well as for this right circular cylinder. We also have to know it for this cone down here, but that's going to be the same equation as this one up here. Okay, so one thing that you should know is that you are given these equations back, way back in your equation sheet that they give you for the SAT math section, but if you have to flip all those pages back and then flip all the way back here and then go back and find the other equation you need and then go all the way back, that's going to waste you time. So what I really recommend that you do is memorize the equations that they give you on that first page of the SAT math section, so that way you don't have to flip back and forth. Okay, because those are common equations that you're going to need to know to solve problems, and if you have to flip back and forth, you're going to waste a lot of time. Okay, so we know that the volume for this right circular cylinder is going to be pi r squared times our height, and we know that the volume for the cone is going to be 1/3 pi r squared times our height. Okay, now since we know that we have two of those cones, we're just going to multiply that volume by 2, and we don't even have to do another volume equals down here because we know that it's going to be the same equation since they each have this 5-foot radius and this 5-foot height. So we're just going to multiply that by 2. Okay, so what we can do is we can take that 2 and just put it right here on top of that 1/3, right? So now we have 2/3 instead of 1/3. Okay, and I'm actually I'll rewrite it just because I want you to see that that's the volume equation there. Okay, so our total volume then is going to be this pi r squared times this height here, which is 10 feet, plus that 2/3 pi r squared times the height of our cone, which is going to be that 5 feet, so times 5 feet. We know our radius for each one is going to be that 5 feet, so we can go ahead and plug in 5 squared for that radius squared. We got 5 squared. Plug it in over here as well. We see we're going to have 5 squared times 5, so that's going to be 5 cubed over here. Our height we see is 10 for our cylinder, so we're going to have to multiply that by 10. Now at this point we're going to have to grab a calculator because we're going to want to know what pi is exactly. So I'll go ahead and find my calculator real quick. Let's go ahead and do that. Alright, so I got my calculator out. Now I can go ahead and plug in. So I know 5 squared is 25. 25 times 10 times pi. And then I take that and I add that to 2 over 3 times pi times 5 cubed, which is going to be 125. And that's going to give me my answer of 1,000. So V is going to equal 1,047.2. So that's going to be answer choice D. Okay, so the big thing that you should really note as a strategy is that you should have these equations memorized. All of those equations on that first equation sheet that they give you on the SAT math section, you should memorize them so you don't have to waste time, okay? As someone who's scored perfectly at back-to-back on the SAT math section, I have all of those memorized, and you should too, because it's going to save you time from going back and forth. So especially if you're shooting for over a 600 on the math section, you should really be looking at memorizing all of those equations, because it's really going to help you save time, and it's a timed test, so you want to save as much time as you can. Alright, so with that, we go ahead and move on to question 26. So we got in the xy plane, the line determined by the points 2k and k32 passes through the origin. Which of the following could be the value of k? Alright, what I immediately look at when I have a pair of points like this, and I'm told that it passes through the origin, if you don't know, the origin is 0.00. Okay, so if you're going to want to put that in your notes if you don't know it, the origin is 0.00, is I'm going to look to find my slope. Okay, so if I'm looking at my slope, if I know my point passes through 0, 0, I've got to have this 0, 0 paired with this and paired with this, and then I can use my slopes to solve for k. So what I'm going to do here is I'm going to take that 0, right? I'll use my slope equation, which is my rise or my y, my difference in my y's over the difference in my x's. Okay, so that 2 as my final x minus my initial x of 0 is going to give me 2 in my denominator. And then my final y value is k minus my initial y value of 0 gives me k. Okay, so k over 2 is going to be my slope. Now I can also calculate my slope from this right here and pairing that with 0 and 0. So I'll go ahead and do that. I see my x value in this case is k, so we'll go ahead and call that k minus 0 in our denominator. Right, k minus 0 is going to give us k as our denominator. Up top we see that we have 32, so we're going to have 32 minus 0. Okay, another thing that you should note is how I picked what was going to be my first term and I kept it the same in my bottom and my top. Okay, you're going to get the wrong answer if you were to do 0 minus 32. Okay, why would you get the wrong answer? Well, you're going to deal with a negative up top when you should be dealing with a positive up top. So what you may want to do, this is something you can do, is you can call this, x2, and you could call this y2, and you could call this over here x1 and y1. But either way, you're going to want to keep those ones the same, right? So you're going to want to call that pair of points, you're going to want each of them to be the first one, and this pair of points over here, each one of them to be the second one. It doesn't matter which one's first, which one's second. It just matters that they're the same, right, for the pair of points. All right, so in this case, we're going to have 32 over k. So at this point, we know that both of those are going to be equal to our slope. So now what we can do is set them equal to each other and then solve for k. So we're going to have k over 2 is equal to 32 over k. We're going to multiply each side by k. Multiply each side by k. Then we're going to multiply each side by 2 to get rid of this 2. 32 times 2 is going to give us 64. K times k is going to give us k squared. So now we have k squared equals 64. Take the square root of k, take the square root of 64, and we know then that k is going to equal 8 because the square root of 64 is 8. So correct answer for the value of k is going to be C. Now one thing I want to bring up because I haven't brought it up yet, and if you've been watching these videos for a while, you know I talk about this a lot, but we always want to pay attention to what this end question is asking. In this case, it's the value of k, which we just solved for, so we're perfectly fine with C being our answer of 8. But we just want to always pay attention to that because sometimes it could ask you for the value of 2k plus 3 or something like that. Okay, so we always want to pay attention to what we're asked at the end. So that's one thing you can put in your notes there. The other thing would really just be making sure that we're paying attention to the word such as the origin, because if we didn't pay attention to this part here, it passing through the origin, we wouldn't be able to solve for this. So it's very important that we pay attention for that as well. So looking for details, especially on these later questions in the math section when it's more difficult, is very important. All right, 27. A rectangle was altered by increasing its length by 10% and decreasing its width by p%. If these alterations and decrease the area of the rectangle by 12%, what is the value of p? All right, well, one thing that you see that I did here is I went ahead and I wrote my equations out as I read through, right? So that's one thing I talked about earlier today. We'll talk about it again. I want to write my equations as I go through. So this right here is a 1.1 L. I'll write that a little bit neater so you can see it better. Another thing with L's, I always write my L's like this so they don't look like a 1 so I don't confuse them. So that's one thing I recommend you do as well. With variables that look like something else, make sure you try to differentiate them. So if I'm using an L, I'm going to draw it like that instead of like that, because that could look like a 1. All right, so I saw that I have a 10% increase in my length, so I wrote 1.1 times whatever my initial length was. And then I saw that I'm decreasing my width by p%, right? So if I'm decreasing my width by p%, then that's going to be 100% minus whatever my p% is, right? And that's going to have to be in decimal form. So what I'm going to do is I'm going to write it as 1 minus p, right? And really what you can do here, in my opinion, the best way to do this is to just call something, we can just call this, we'll call it q, right? qw. And in this case, q doesn't necessarily mean much, right? It's really just a placeholder. But the reason I do that instead of doing 1 minus p or something like that is just because it's going to be easier to solve that way. Because if we can solve for what w is getting multiplied by, then we can just take 1, subtract whatever q is, and then solve for p. So that's really just going to be the way that I think it's easier to visualize this, in my opinion. So that's how I'm going to go ahead and do it. All right, so what I see here is I'm going to have 1.1 times L, right? And I know I have to solve for my area. My area is decreasing by 12%. So if my area goes down by 12%, I know my area is my length times my width, and I have to multiply that by 0.88 since that's a decrease of 12%. So I know I have 1.1 L times whatever is times my width is going to give me that 0.88. So what I'm going to do here, I see that this could be rewritten as 1.1 QLW is equal to 0.88 LW. I see that my LWs are going to cancel, right? I divide each side by LW. They're going to cancel out. So now I'm going to have 0.88 equals 1.1 times Q. I divide each side by 1.1 to isolate Q. Now I plug this in my calculator. I'll go ahead and plug it in real quick. 0.88 divided by 1.1. I see that that's going to give me 0.8, right? So Q is going to equal 0.8. Okay, now that it means that I have a 20% decrease, right? So my correct answer there is going to be C for 27. So how do I know that that's a 20% decrease when Q is 0.8? Because I'm taking 0.8, multiplying it by my original width, which means that's a decrease of 20%. Okay, so that's going to be answer choice C there. So you see that if I was going to use that 1 minus p, right? If I was going to use 1 minus p, that would just get kind of, it's just going to add steps. So that's why I didn't do it, because it's going to add steps because you're going to have to go through, solve for p, then convert p into a percentage, and it's just a lot more work than finding what is multiplied by w and then seeing, oh, it's 0.8, that means a 20% decrease. So in my opinion, that's just an easier way to do it with some less steps. So you can take your pick on how you want to do it that way. In my opinion, that's the easier way to do it. But big tip for 27 is writing out our equation as we read through to avoid having to read through twice and waste time doing that. All right, 28, in planning maintenance for a city's infrastructure, a civil engineer estimates that starting from the present, the population of the city will decrease by 10% every 20 years. If the present population is 50,000, which of the following represents the engineer's estimate of the population of the city t years from now? Okay, well, this is going to be an equation where we have to list our starting value first, which is 50,000. We know we're decreasing by 10% every 20 years. So we're multiplying by 0.9 every 20 years. Okay, that's a decrease of 10%. So t is our years, okay, in years from now. So every 20 years is when we decrease by that 10%. So that t is going to have to equal 20 to have that 20 over 20 to keep that as a 1, okay? So that's what our equation is going to have to be there, and that's, we see that that's answer choice D, so D will be our correct answer there. So this one right here is really just understanding how to set up that exponential growth or exponential decay question, okay? So this right here is an exponential decay because we're decreasing from our initial value. I talked about in week 1 how this equation is set up. We're going to have our initial value here. Then we're going to have whatever our change is going to be, so in this case a decrease of 10%, and then our power is going to be when that change occurs, right? So we see that that's going to happen every 20 years is when we lose that 10%. So we need that t years set over 20, okay? So answer there is going to be D. So that one's really just understanding that exponential growth and decay equation. If you want to brush up on that, you can Google it if you want, or you can go back and rewatch one of my videos from week 1 where I talk about the math equations list. Either of those are good choices. All right, 29. We've got handedness, we got male, female, right, left, and then we got our totals. So I've got a lot of text here, but unfortunately, since my table is not filled in, I know I'm going to have to read it. The incomplete table above summarizes the number of left-handed and right-handed students by gender for the 8th grade students at Keisel Middle School. There are 5 times as many right-handed females as there are left-handed females. Okay, so 5 times as many right-handed females as left-handed females. And we see that there are 9 times as many right-handed males as left-handed males. So 9M versus M. If there's a total of 18 and then a total of 122, I already see that in my table, which of the following is closest to the probability a right-handed student selected at random is female. Okay, so I see I'm looking for probability. I have a right-hand student, so my total is going to be out of 122, probability that they're female. So I'm looking for the value of 5F over 122. That's going to get me my answer. So I got to solve for that somehow. Okay, so you saw that as I read through this, I filled in my table. That's something I'd recommend you do as well with the SAT math section. So when I read that there were 5 times as many right-hand female students as left-hand female students, I called my left-hand female students F, and I called the right-hand female students 5 times F, right? Because it's 5 times as many. I did that same thing with males, except males it was 9 times as many. All right, so now what we can do is go ahead and set up a system of equations to go ahead and solve for what F is, because that's what we need in order to solve for that probability. So we see that we're going to have F plus M is going to equal 18 because that's that column going down for the left. So F plus M is going to equal 18. And then we see we're going to have 5F plus 9M is going to equal that 122. So now what we're going to want to do is we're going to want to substitute in a value of F for M, right? So if we're going to rearrange our equation up top, we would have M equals 18 minus F, right? We'd subtract F from each side, and we'd see that M equals 18 minus F. So at that point, we'd plug that in for that 9M. So we're going to have 5F plus 9 times 18 minus F, and that's going to equal that 122. All right, so at that point, we multiply that 9 by 18, plug that into our calculator. I think that's 168 if I'm not mistaken, but I could definitely be wrong. It's 162, so 162. Okay, so I'm going to have 162. I know I'm going to have to subtract that from each side to get rid of it, right, because I want to set it equal to a constant. 122 minus 162, that's going to give me negative 40. I see I also am going to have to multiply my 9 by my negative f, so that's going to be 5f then minus that 9f, 5f minus 9f, that gives me negative 4f. So negative 4f equals 40, divide each side by negative 4, that gives me then that f is going to equal 10. So the number of female left-hand students will be 10. I know I have to multiply this 10, my number of female students, by 5, put it over 122, and then find it as a decimal. So that's going to be 50 over 122, and that's going to be 0.41. So that correct answer there is going to be A. That's our probability. All right, so the probability a right-hand student is female is going to be 0.41. So that one right there is not too bad. The big thing as far as that one, the big thing there, honestly, a lot of it was not being intimidated by all of these words, okay, and having an empty table. If you were willing to persevere and go through and solve it, the math behind it isn't too terribly difficult. It's actually not that rough of a problem from a mathematical perspective. It was really just you having to have the perseverance to see all of this text and be willing to go through it because you didn't have another choice. There was no shortcut around this. You had to read it in order to find those ratios, but once you did, the math behind it isn't really too bad at all. So that one there, it's really making sure that you're confident and not intimidated. So that's a big thing there. Don't be intimidated if there's a lot of text because the math behind it might not be too tough. Then after that was setting up ratios, which I talked about there, and then just solving for the probability. So that one's not too bad at all. Really just having to persevere there was all it was. All right, now with that, we got our last problem for the math section before we switch to the reading. So we got question 30. So in the equation above, B and C are constants. If B is C minus 1/2, so B equals C minus 1/2, which of the following is true? All right, well, in order to solve for this, I'm looking at my stacked equations here. And what I'm going to look to do is I'm going to look to get them equal to each other. That way I can solve for what that B, or what X is equal to, right? Because it's telling me immediately, since I look at my answer choices and they all say X is Y and then plus or minus something, that I have to solve for whatever X is, right? So if I want to solve for what X is, I want to get both of these equations up here equal to the same thing. So what I'm going to do there is I'm going to go ahead and I'm going to subtract 5x from each side and I'm going to subtract 5y from each side. So when I do that, I'm going to have in my top equation 3x. I subtract 5x, that's going to give me negative 2x then. So negative 2x plus b. I know that b is equal to c minus 1/2. So that's going to be plus c minus 1/2. and that's going to equal negative 7, right? Because that's what I'm trying to do, is get those negative 7s to both be what each equation is equal to. Then I'm going to have to subtract 5y from my bottom equation, so 3y minus 5y gives me negative 2y. Negative 2y plus c then is going to equal negative 7. So at this point, I see both my equations have plus c. They both equal negative 7. I see I have negative 2x, right? Well, what is x going to have to equal for these equations to be the same? Well, I need to get rid of this minus 1/2 because I don't have that in my bottom equation. So I want to get rid of it. So if I want to get rid of that, then x is going to have to be, we'll go ahead and write it down right now. We know there's going to have to be a y in for x, right? Because we have to have negative 2y from right here. So we know there's going to have to be a y there. And we know we have to have plus 1/2 to get rid of that minus 1/2. So negative 2 times what gives me plus 1/2? Well, that's going to be times negative 1/4. Okay, because when we take this negative 2, multiply it by negative 1/4, that's going to give us positive 2 over 4, which is positive 1/2. Positive 1/2 gets rid of this minus 1/2 here, right? Gets rid of that minus 1/2 there. And we'll be left then with negative 2y plus c equals negative 7 in both equations. So we know our correct answer then must be x is y minus 1/4. So that's going to be answer choice A. So that one also not too terrible. Overall, questions 24 through 30 of SAT Practice Test 3, in my opinion, aren't too tough at all. They're, in my opinion, a bit easier than some of the ones that I've seen on Practice Tests 5 through 10. Given the circle above, AB is a diameter. If the length of arc ADB, which means it's going to be this arc here, from A all the way to B, what is the length of the radius of the circle? Okay, well, AB is our diameter, and I'm told that the length of that arc from AB to D is 8 pi. Well, if I have a diameter here, I know that's splitting my circle in half. Okay, so that arc length has to be half of my total arc length, or half my circumference. I know my circumference is 2 times my radius times pi. Okay, so if I have half my circumference is 8 pi, then to get my whole circumference, I have to multiply by 2 to get rid of that half of my circumference. So that's going to give me 16 pi is my total circumference. So 16 pi is my circumference C. I know that that's equal to 2 times my radius times pi. So now I divide by 2 times pi to solve for my radius. Divide each side by 2 times pi. 16 pi over 2 pi, my pi's will cancel. 16 over 2 is 8. So I know my radius then is going to equal 8. So correct answer for 24 is going to be C. Okay, so as far as this one goes, the big tips here is understanding that if we have a diameter AB, then that's splitting our circle in half. That's splitting our circumference in half as well, right? So ADB, that's going to be our circumference over 2. Okay, so understand if we have a diameter, that's splitting our circumference in half. Okay, the next thing was understanding that equation for the circumference, that it's 2 times pi times the radius. And then once you had that, it was just using algebra to solve for what the radius was. So that one's not too bad at all. All right, 25. Okay, 25 looks very complicated at first. It's not as complicated as it looks, and you may think at first that you're going to have to go A through D, and you actually don't, and I'll show you why here in a minute. So we have the polynomials f of x and g of x are defined above. Which of the following polynomials is divisible by 2x plus 3? Okay, if something is divisible by 2x plus 3, then that means 2x plus 3 is a factor of it, okay? So if 2x plus 3 is a factor of the equation, then that's what we're looking for in option A through D. We need 2x plus 3 to be a factor of one of these equations. So first thing I'm going to do is I'm going to look at f of x up here, and I'm going to look at g of x. Now, what I see in f of x is that I could factor out 2x, okay, because 2x is in every term. It's in 4x, it's in 6x squared, and it's in 2x cubed. So I'll factor out my 2x, and then I'll have 2x times x squared plus 3x, and then plus 2. Okay, so what do I see with this? Well, I see that g of x is x squared plus 3x plus 2, and that I can also have that up here in f of x. Well, then I could restate f of x, and I could just say that that's equal to 2x times g of x. Okay, so f of x is 2x times g of x. All right, well, now what I see is I have 2x here. Okay, that's the first part of my factor down here. So I have 2x right there. So I have 2x times g of x then times what? Well, I'm going to want to look for something with plus 3. Okay, I'm going to want to look for something that has a plus 3. And then what I'm going to look for is something with g of x. Because I know I want to get my 2x plus 3 together. And if I know that I have 3 times g of x as well, then what I can do is I can say 2x plus 3 times g of x. Okay, because that g of x then will get distributed here and here. So what I'm looking for is an equation that is set up like this, right? So we know that f of x is equal to 2x times g of x. So the first thing I'm going to look for is something with f of x. I see c and d have a coefficient in front of it, so I don't want those. So I'm looking at a and b. Next thing I'm looking for is a plus 3gx, and I see I have that in option B. Okay, so that's the quickest way we can get to our answer in 25, and that's the most efficient way by far. Okay, if you had to go through A through D without knowing this pattern and just go through and sort and divide, that's going to take you a long time. Okay, so that's why it's important to understand these patterns that we can use with math and these sort of tricks we can use in order to find that answer so much faster. Okay, so that's really important to understand here. Okay, so that one right there is very important. Notice how quick we did that one. That one really only took us about 2 minutes. If you were to have run through A through D and divided each one of those to find your right answer, that would have taken you a very long time. So understanding that relationship when we can get that 2x times g of x equaling f of x up here, how important that is. And then once we have 2 of x, we're just looking to add 3. That way we can factor out that 2x plus 3. Okay, so that's really what that's all about. Okay, so answer there is going to have to be B for 25. All right, now we've got question 26. So we have x and y are numbers such that negative y is less than x, which is less than y. Which of the following must be true? Okay, anytime we have a situation like this where we have to determine whether 1 through 3 are true, we just got to go through. There's really no secret formula with these ones. We just got to run through 8, 1, 2, and 3, see which ones are true, which ones are false. So let's go and start with 1. The absolute value of x must be less than y. Well, what I'm going to do here to make this easy to figure out with all of these 3 things is, since I have all variables up here, I kind of don't like that because that can be a little bit tricky, especially if you struggle to work with letters and numbers. So what I'm going to do is I'm going to pick values for these. I'm going to insert them. That way I can see and then plug them into these rules. Okay, so we're going to call x 3. And if y has to be greater than that 3, then y could be 5. And then we have negative y, which must be negative 5. Okay, so we have a 5, a 3, and a negative 5, a 3, and a 5. Okay, so is the absolute value of x less than y? Well, let's see. Absolute value of x is 3. Is that less than y of 5? Yes. Okay, so 1 is going to be true, right? It has to be true. So 1 is going to be true. All of our answers have that, so that doesn't really help us. Now, what about 2? And that's actually an error I just made. Okay, that's something you shouldn't do. Notice how I checked if 1 is true or not. I shouldn't have done that because I should have seen that 1 is included in all my answer choices, so I actually just wasted time. That's one thing that you should do anytime you have a question with 1, 2, 3, is you should look at your answer choices, see if there's any that are included in all of them, because then don't waste time checking it. Okay, I just made a big mistake there because I wasted time checking something that didn't matter. Okay, so that was a mistake there. All right, number 2. So we have x greater than 0. Well, no, we see that 3 is not greater than 0, so we know that that's going to be wrong because we'd plug in 3 here. 3 is less than 0. Or I'm sorry, hang on a minute. I totally just misspoke there. X is greater than 0. Okay. Can x be greater than 0? Yes. Does it have to be? No. Okay, I totally just misspoke there again. All right, so as far as whether or not x has to be greater than 0, it can be greater than 0, but it doesn't have to be, and here's why. If we were to take this out and plug in negative 2, does this still work? It does, right? 5 is still greater than negative 2, and negative 2 is still greater than negative 5. So we see x doesn't have to be positive there. So 2 does not have to be true. Keep in mind it says must be true. Okay, what has to be true? We know that the absolute value, or I guess we don't even have to go through that because that one's already in all of these. As far as 3 then, actually we don't even have to do anything now because we've already seen then that 2 is incorrect. So any answer with 2 we can get rid of. So we can get rid of D, we can get rid of B. We know that 1 has to be true because it's in all of these. So, and then the question is 3 true? Is y greater than 0? Yes, y has to be positive. Okay, y has to be positive because it has to be greater than the negative version of itself, right? So if we were to have negative 2 for y, right? Let's say that, or we'll go ahead and pick negative, we'll pick negative 1 for y, right? If we had negative 1 for y and then we had negative y, well, this would make this 1, okay? Is negative 1 greater than 1? It's not, so that's incorrect, okay? So y is going to have to be greater than 0. So 1 and 3 will have to be correct, so our answer there is going to have to be C. So 26 answer there is going to have to be C. All right, so that takes us through 26. Now we've got 27. So we've got the relative housing cost for U.S. city is defined to be the ratio of the average housing cost for the city over the national housing cost, expressed as a percent. I've got the graph of it. Now I'm asked, the scatter plot shows relative housing. I already know that. The line of best fit is also shown and has an equation, y equals 0.0125x plus 61. What best explains how the number 61 in the equation relates to the scatter plot? All right, well, this number 61 is my y-intercept, which I know is my relative housing cost in pretty much an abandoned city, right? A population at very close to 0. Okay, so that's pretty much the lowest housing cost I can get as a function or a percent of the national average cost. So that's pretty much the lowest I can get. Keep in mind, it doesn't mean that Nothing is below that because that is the average that we're working with here. So it's possible there are some that are less than that 61%, but it's not very likely. So let's go ahead and run through A through D, see what our options are. So option A, in 2005, the lowest housing cost was about $61 per month. No, okay, that 61 is talking about the percentage of the national average. So not per month, that's incorrect. B, in 2005, the lowest housing cost in the United States was 61% of the highest. No. Once again, this is an average of the housing cost as a percent of the national average. Okay, so it cannot be $61 per month, and it can't be 61% of the highest housing cost. So option C, in 2005, even in cities with low population densities, which is what that reference to this 0 here is, low population density, housing costs were never below 61% of the national average. Okay, we know that it's possible that there are some that are below that 61% of the national average because this is a line of best fit. Okay, with a line of best fit, there can be points that are below it, okay, because the line of best fit pretty much takes the average of those points, right? Or it kind of plots basically the best fit line of those points, but there can be points that are below it. So C is incorrect. D, in 2005, even in cities with low population densities, housing costs were likely at least 61% of the national average. Okay, that is true, okay? In 2005, these cities with low population densities, their housing costs, according to our line of best fit, which is why we say we're likely, okay, at least 61% of the national average, right? That's our y-intercept. We can't get lower than that. We can with points, right? We can have those points that are lower than that, but we can't have anything that fits our line of best fit lower than that, right? So it's most likely that those low density populations, their housing costs are at least 61% of the national average. That's likely according to the scatter plot, or not the scatter plot, I'm sorry, the line of best fit, not the scatter plot, line of best fit. So answer there is going to be D. All right, 28. So 28 says, which of the following is an equivalent form of the function f above in which the minimum value of f appears as a constant or coefficient? Okay, anytime I'm asked for some value to be shown as a constant or a coefficient, I'm going to calculate that value first and then just find my answer choice that has it, because sometimes there's only one that has it, and in that case, it makes it very, very easy. All right, so I know that my lowest point, that's going to be midway between my two x-intercepts. Okay, between my two x-intercepts is my vertex. Okay, so I see I have an x here and a positive x here. So I know it's going to be x squared, so that's going to be my largest exponent term, right? So I know my graph is going to open up like this. Okay, if I open up like this, my minimum is going to be between my x-intercepts. Okay, between my x-intercepts. So I look at my options here. I see I have an x-intercept at 4 because x minus 4, we're going to flip the sign. We're going to have an x-intercept at 4 then. And my other x-intercept is going to be where we flip the sign here from positive 6 to negative 6. Okay, so that midpoint between those I know is going to be at negative 1 because the midpoint between negative 6 and 4 is negative 1. So that means I plug in that negative 1 to x, solve for f of x, and that will be my minimum value. So I got negative 1 plus 5, negative 1 plus, or I'm sorry, negative 1 plus 6, that's going to give me 5. Then I have negative 1 minus 4, that's going to give me negative 5. So we have 5 times negative 5. We know that's going to give us negative 25. Okay, so I find my answer with negative 25. I see the only one that has that is D, so D will be my answer there. Okay, so that one, the big tip there is understanding that if we're asked for some value shown as a constant or coefficient, we're going to solve for that value first because sometimes there's only one answer choice with it, and then we don't even have to worry about this part, this part, this part, or any of that. We just find the one that has that constant or coefficient. So answer there is going to be D for 28. All right, now we've got 29. If x is the average, the arithmetic mean of m and 9, y is the average of 2m and 15, and z is the average of 3m and 18, what is the average of x, y, and z in terms of m? All right, well, this means that we're going to have to sum our x, y, and z terms and then divide them by 3 since that's how many terms there are. Okay, so if x is the average of m and 9, then that tells us that we have m plus 9 over 2 because there's two terms. There's a 9 and there's an m. Okay, so that's what x is. Now we're going to have to add whatever y is. We know y is the average of 2m and 15. Okay, keep in mind there's two terms there as well, so we're going to put that divided by 2 as well. Next, we have to add z, which is the sum of, or the average of 3m and 18, 3m plus 18 then, also over 2 because there's two terms. Now we go ahead and we add these, okay? So we have an m here plus 2m, that gives me 3m plus 3m here, that's going to give me 6m. Next, I have a 9 plus 15, that gives me 24. 24 plus 18, that gives me 42. Okay, now that's all split over 2, but then we also have to divide that by 3 because we had the x term, the y term, and the z term. So we have to divide that by 3 terms as well. So 6m plus 42 over 2 is going to give us 3m plus 21. Then we divide that by 3, and that's going to give us m plus 21 over 3, which is 7. So m plus 7 will be our answer there, m plus 7. Okay, so that one right there, not too bad. Really just understanding, we make sure we have a common denominator here before we add, which we saw that we did. Then we added our terms, and then the big error that you can make here is if you forgot to go ahead and divide by 3 right here. If you forgot to divide by 3, you see that you would have answered D, 3m plus 21, which would have been incorrect. So you got to remember how many terms you have and to divide by that many terms. So that one right there is really making sure you're paying attention to those little details, because if you're not, then you're going to get that one wrong. Okay, I'm going to erase this just so that we can see that problem on the right for number 30. And then let's get into 30. So it looks like today we'll probably end up finishing up fairly early with the math section, but that's okay because we're already still ahead of where I thought we were going to be for this 90-day course, so I'm not too concerned about us finishing early here because we're already ahead of pace, so we'll be okay. So we've got 30, the function f of x equals x to the third power minus x squared minus x minus 11 over 4. It's graphed in the xy plane. If k is a constant, such that the equation f of x equals k has 3 real solutions, which of the following could be the value of k? All right, 3 real solutions means that we have 3 intercepts of this f of x equals k, which is just going to be some y value, right? Some y value, whatever it may be, some y value. It's got 3 real solutions. That means it's got 3 intercepts, okay? So I need this graph of this f of x right here, this big equation here, which is already graphed in this plane. I need it to cross my constant 3 times. I see I got 1 cross here, 2 cross here, and 3 cross here. So that y value there needs to be that negative 3. Okay, so that k then has to be negative 3. So answer there is going to be D. Okay, that one right there is a very, very easy question to come at 30. Keep it an equation above. We're told the equation of a circle in the xy plane is shown above. What's the radius of the circle? All right, so we know that our equation for a circle is x minus h squared plus a y minus k squared equals the radius squared, where our center is hk, right? So the thing that I look at up here, since I see that I have an x term here and a minus 2y term there, right? What I know is I've seen this type of question before, right? And if you haven't, I'm about to teach you it, so pay attention. What I see is I don't have this in my form that I'm given down here, right? This is the normal form I'd be used to seeing a circle equation in. Okay, so if I see it in a form like this up here, where I don't have those parentheses, then what I know about my radius term is I'm going to actually have to find it, right? I have to find what that r squared term is. So in this case, I see I have x squared and then a plus 4x. So I'm actually going to have to find the factor there, right? So I'm going to have an x, obviously. We know that it's going to get squared because that's what we see in our equation down here, right? This equation I wrote right here. So the question is, how do I get to plus 4x? Well, that's going to be x plus 2, right? Because x plus 2 squared, if we're going to write this out, x plus 2 times x plus 2, we're going to have a plus 2x, and then we'll have plus 2x to give us plus 4x. Okay, so how does that help me solve for my radius? Well, now that I have that, I can solve for this part right here. This 2 has to get multiplied by that 2, which is going to give me a plus 4 over here. Now when I add 4 there, I got to add 4 to this negative 1 as well. So now I have that negative 1 plus 4. So now I'm going to do the same thing I just did with my x term with my y term. So I see I have minus 2y, which means I'm going to have y minus 1 squared, because y minus 1 times y minus 1 is going to give me a y squared, and then it's going to give me minus 2y, and then it's going to give me plus 1. So since I have plus 1 here, I also have to add 1 over here, okay? So I add 1 to each side. I see I have 4 plus 1, which is 5, and then I got negative 1 then plus 5. I see that gives me 4. Now keep in mind, 4 is not my correct answer because that's my radius squared. Okay, so 4 is equal to my radius squared. So I have to square root each side to solve for my radius, and I know my square root of 4 is 2, so my answer there is going to be A. Okay, so that's really one important thing to understand when you're dealing with radius of circle questions, is that that's going to equal that x squared. It doesn't equal the radius, it equals the x squared. I'm sorry, the radius squared. Okay, it equals the radius squared, which means that you have to take the square root to find the radius. So 24, answer there is going to be A. So the really big thing there is understanding that if you have it in this form up here that we're given to from our equation, that we got to look to find the factors and then use those factors then to add to each side in order to find what that radius is, or what that radius squared is, and then use the radius squared value to find the radius. All right, so with that, let's go ahead and switch over to question 25. We've got the graph of the linear function f has f-intercepts at a and 0 and o and b, or 0 and b in the xy plane. If a plus b equals 0 and a cannot equal b, which of the following is true about the slope of the graph f? All right, so one thing I look for whenever I'm given two points like this, right, and I have two missing variables, in this case A and B, is I'm going to look to create a slope formula, okay? So in this case, it says directly something about the slope. It won't always say something directly about the slope, but anytime I see that, where I have two variables missing like this, I'm always going to think to use the slope formula. So that's just one thing you could put in your notes there. Okay, next thing, I have an if statement here. Notice how I underline that. Anytime I'm given an if statement, it's probably important to the math section, so I pay attention to that. Okay, also we have A cannot equal B, that's important as well. Okay, so if A plus B is going to equal 0, what does that mean? Well, that means we're going to have A equal either a negative or positive number, but whatever it is, B is going to have to equal the same absolute value but the opposite sign, right? So let's say that A was negative 3, then B would have to be positive 3, because negative 3 plus positive 3 gives us 0. Okay, and that's what we're told right here in this if statement. Okay, also they can't equal each other. Okay, this right here, this works because one is negative 3 and one is positive 3. Okay, that works because they don't equal each other. Their absolute values can equal each other, but they themselves cannot equal each other. Okay, so with that, we can go ahead and set up our equation then. We'll go ahead and use those numbers, right? So we're going to have A, we said was, we could plug in the numbers or we can not. We'll end up plugging the numbers in eventually, but I'll actually just go ahead and show you how we're going to do it using A and B because that's the way that I kind of want you to learn it. So let's go ahead and do that. So let's say that we're coming up with our slope formula, right? We know our slope formula is going to have our second points. So we're going to pick this one to be our second points, right? So we're going to do our x number 2 and our y number 2 will be those, and then our x1 and our x and our y1 will be on this A and 0. Okay, so we're going to go ahead and start with up top, we're going to have our rise or our y value. So we're going to take y2, which is b, subtract y1, which is 0, set it over x2, which is 0, subtract x1, which is a, and that gives us our slope. Okay, we go ahead and simplify that. B minus 0 is b, 0 minus a is negative a, and we see our slope is b over negative a. Okay, so at this point, we can just go ahead and plug in our values that we just determined, right? We made up some numbers just to make it easier on us. So we plug in b, we know b is 3, all over negative 3. We know negative 3 makes a positive 3, which is 3 over 3, which means that's equal to 1, which is a positive. Okay, so we know answer there is going to be A. So one strategy you can use in things like that, where you have two variables like that, and your situation where you have to find a slope and then determine something about that slope, is use those if equations to determine artificially generated numbers. Okay, artificially generated numbers just means you made them up, right? So use that if statement. In this case, it was two if statements, to go ahead and create those artificially generated numbers and then plug them in down here in order to find what your slope will be, right? In this case, it's going to be positive. Okay, so that's one strategy that you can use and that I would use if I were doing this. So that's 25. 25 answer there is it's positive, which is A. Now we got 26. So I see I've got a graph here. I'm told the complete graph is shown in the xy plane. What is equal to 1? Okay, which of the following is equal to 1? Okay, well that's going to be whatever points intersect this 1 right here. Okay, I see that we got that at negative 4 right here. So negative 4 is going to be one value. And I see I have a list also, 1, 2, 3. Okay, so f of negative 4, yes, that does equal 1. So that's a check. That's a true statement. Next we have f of 3 over 2. That's 1.5. I know 1.5 is going to be right where this arrow is pointing on this graph right there. I see that does equal 1. So that's also correct. Next I have f of 3. I see that that also is intersecting my point of 1, right? That is equal to 1. That is also true. So answer there is 1, 2, and 3. That one right there is pretty easy. If you watched my video from yesterday, I talked about how SAT practice tests 2 and 4, they don't seem to get too much harder as you go on. That's kind of changed in my opinion with SAT practice tests 5 through 10, and that's more indicative of what the SAT will be. They will get more difficult than this as you get to these later questions in my opinion. Generally, if you look at practice tests 5 through 10, the questions right around 24 through 30 will be harder than what you're seeing on this one, for example. So that's just something to keep in mind. But either way, these are still good practice tests to use for teaching, just because it's material that you still are going to need to know and that could still show up. Just maybe not as late as this one is 26. I would expect this one to come more around 20 if I'm being honest. In my opinion, on a real SAT, I would expect this type of question with how easy it is to be somewhere right around 15 to 20. So, all right, now we've got question, looks like we're on 27 now. Let me just check. Yes, we are on 27. All right, so we've got an insulated and uninsulated or non-insulated. We got two different points. We got temperature y-axis, time x-axis. So 2 samples of water of equal mass are heated to 60 degrees Celsius. 1 sample is poured in an insulated container, other in a non-insulated container. Samples are left for 70 minutes to cool in a room having a temperature of 25 degrees Celsius. Graph above shows temperature of each sample at 10-minute intervals. What correctly compares the average rates at which the temperatures of the 2 samples change? Okay, I'm going to go take a look at my graph, find what kind of rates I'm looking at for change. I see my non-insulated has a very, very large change at the beginning, okay, and also right here, another very, very large change. Okay, then I see its change really starts to level off to pretty much no change from right around 50 to 70. Okay, whereas my insulated container, we have pretty much steady change going down here, and really pretty much a steady change overall, whereas it's very, very drastic at first with the non-insulated, and then pretty much no change with the non-insulated after basically about 40 minutes. So I'm going to look for an answer choice that says that. Okay, I see A and B. They say in every 10-minute interval, the magnitude of the rate of change of temperature of the insulated is greater than that of the non-insulated. Okay, both of them are saying that the magnitude of rate of change of one is greater than the other, but that's not true because the rate of change of the non-insulated was greater at first, okay, but then it was less than the insulated at the end. So we need something that shows that difference over time. Okay, so let's look at option C. In the intervals from 0 to 10 minutes and 10 to 20, the rates of change of temperature of the insulated samples are of greater magnitude. Okay, that's incorrect. We know that in those first intervals, 0 to 10 and 10 to 20, the rates of change of the temperature of the non-insulated sample are of greater magnitude. Okay, and then in 40 to 50 and 50 to 60, the rates of change of temperature of the insulated sample is of greater magnitude. So D is going to have to be our correct answer for question 27 because it's correct according to the data in the graph. So D is our correct answer there. That's 27. All right, so as far as tips there, really the big thing is just understanding how to interpret your graph. Okay, one thing that you look at most of the time, if not all the time, whenever I have a graph question, you'll see me annotate it. That's something I highly recommend you do as well. With graphs, it can be very, very helpful if you annotate your graph. It can prevent you from making simple mistakes. Whereas, for example, if you were trying to find an intercept of something and you just glanced over, like say you had to find where something equaled this 10 here and you just glanced over and you accidentally looked up to the 20 line, you're going to make mistakes. So you'll always see me drawing lines on my graph and annotating it. That's really something I recommend with graphing questions. All right, 28. So I've got a graph here. In the xy plane, ABCD is a square and point E is the center of the square. The coordinates of points C and E are 7, 2, and 1, 0 respectively. Which of the following is an equation of a line that passes through points B and D? All right, so an equation of a line that passes through points B and D. Okay, here's one thing I'm immediately knowing. I know this is a square, and I know my diagonals that cross like this form a 90-degree angle right here. Okay, they form 90 degrees angles all around. Okay, so I know my angle, or I'm sorry, my line B to D, it's going to be perpendicular to my line A to C because it's at a 90-degree angle, which means it's perpendicular. So I know that I can solve for my slope from A to C because I'm given my points C and E, which I can use to find the slope of this line. I can find the slope of it, which is M, we'll call it. So I'll find the slope of that line, and then what I'm going to do is I'm going to take that slope, and I'm going to find the opposite reciprocal of it, and that'll be my slope for my line from D to B. So that's what we're going to start doing. So we have E and C, right? That's this line right here. We see C is here, we see E is here. Let's find the slope there. What we're going to do is we're going to call this point here 7, 2. We're going to call that x2 and y2, and we'll call this point here x1 and y1. All right, so I'm going to zoom in a little bit so you can see it better. Now let's go ahead and write our slope equation. Okay, we know our slope. We're going to take our y2 up top because that's our rise over run. Y2 we know is 2. We subtract 0 because that's what y1 is. Now we take x2, which is 7, subtract x1, which is 1, and we're left with 2 over 6 then, okay, which is equal to 1 over 3. So I know my slope from my C to E is going to be 1/3, which means that the slope of my B to D line, right, my perpendicular line, it's going to be the opposite reciprocal. Opposite means we flip the sign, so since it was positive 1/3, we're going to flip it to a negative. Then we take this 3, flip it up, and we take this 1 and flip it down. Okay, so now we'll have 3 over 1, which we know is 3. Okay, so we'll have negative 3x, that's going to be our slope there. The next thing that I have to check, I'm going to check my answer choices, see if that gives me my correct answer right away. I see it gets rid of C and D, but we still have A versus B. Okay, they each have that negative 3x. Okay, so we're going to distribute that negative 3. I don't know if it's showing up on your screen right now. My screen's kind of going wonky. Okay, we're going to distribute that negative 3 over. Okay, so now we got to find where that y-intercept is. Okay, option A says it's at -1. Let's take a look. Well, look at when we drew this line. Okay, it's nowhere near that -1. We see it's at 3. Okay, so answer there is going to be 3. We go down, find an answer with 3. We see that negative 3 times negative 1 is going to give us positive 3. Okay, so answer there is going to be B, not A. B, not A. So B is our correct answer there. That's question 28. All right, now we've got question 29. So we've got a system of equations. We have A and B are constants. Which of the following values of A and B does the system have exactly 2 real solutions? All right, what I'm going to look to do here is I'm going to plug in this 3 that I have for y onto my underneath equation here. So I'll have 3 is equal to a squared plus b. Now at this point, I'm going to look to set this a to x squared term equal to the rest of my equation. So I'll have ax squared, and that's going to equal then that 3 minus b. I'll subtract b from each side to get rid of it over there. So then at this point, what I'm going to do is I'm going to think logically, okay? So if I have a, and let's say that a is positive, okay? Well, we know x squared times x squared, it's always going to be positive, because if it's a negative squared, negative times a negative is going to be positive. If it's positive squared, that's also positive, okay? So this is going to be positive. Now let's say that a is positive. So we'll say if a is greater than 0, okay? So a is positive. Well, then we have a positive number equals 3 minus b, right? Now what if a is negative, okay? What if a is less than 0? Well, if a is negative, then x squared is still positive, so then that's going to have to equal a negative number, right? So then it's going to have to be 3 minus b. B would have to be, in that case, if a was less than 0, then we know b would have to be greater than 3, right? We would have to have 3 minus a number greater than 3, so b would have to be greater than 3, okay? And now if a is positive, right, in this case, then b has to be less than 3. B's got to be less than 3. So now that I've determined that criteria, I can just find which answer choice fits that. Okay, so let's look at our ones with a being greater than 0 first, just because there's really no reason I chose to do that. I just picked one, right? So let's say a is greater than 0. Is b greater than 3? Well, we see we have c, a is greater than 0. Is b less than 3? I'm sorry, I misspoke. Is b less than 3, right? That's what I had written down. Is b less than 3? No, we see b is greater than 3, so c is wrong. Option A, is b less than 3? No, it's equal to 3, so that's wrong as well. So now let's look at our other options where a is less than 0. I'm sorry. Where a is less than 0, so a is negative. Is b greater than 3 in those? We see b is greater than 3 in option B, right? We have a is a negative, which is less than 0. That fits our criteria, and we see that b is equal to 4, which is greater than 3. So b would be our correct answer for 29 there. So right there, what we did is we found this ax squared term, right? And then we used logical reasoning, right? It being positive here, in order to create a system of criteria, right? A series of if statements. These are our if statements in order to break down our answer choices and find the correct answer. Okay, that's really the only way you can do that, and that's also the fastest way to do it. So that right there takes us through 29. That one right there is a little bit of a more difficult problem. There's not a whole lot that I see that are similar to that one. As far as on other practice tests, that's kind of a unique problem, but still you could definitely see it on the SAT, so it's certainly important to know how to do it. Okay, that's definitely that one right there, that one is definitely worthy of a 29 spot. Okay, that one is certainly a bit more of a difficult problem. I would definitely consider that worthy of that 29 spot right next to that 30. 30 being usually the hardest problem in the SAT section for math. All right, now we've got 30. So like I said, this one's generally the hardest problem on the SAT math section. So with that, let's go ahead and get through it. So we got the figure showing a regular hexagon with sides of length A. So sides of length A. And a square with sides of length A. Okay, so we've got those side lengths A. If the area of the hexagon is 384, 384 times the square root of 3 square inches, what's the area in square inches of the square? Okay, we know this area in square inches of a square is its side squared, which we know is a squared in this case because each side is a. So we're going to have to solve for a in order to find that area of that square. Okay, so what I'm going to do here is I have this hexagon here, which I'm going to split into 6 different triangles. Now each triangle is going to have the same side length because in a hexagon like this, right, we split that 360 degrees of this circle into 6 different pieces. Now when we do that, 360 over 6 gives us 60 degrees. So all of them are going to have 60 degrees right there. Now we have 2 identical side lengths here, 2 identical side lengths, which means that we're going to have identical side lengths down here, right? This length has, identical angles, okay? So the angle here has to equal the angle here, okay? Because that's an isosceles triangle with 2 that are the same, so those base angles have to be the same. So they're both going to have to split that 120 over 2, which means they're also going to have to be 60, okay? And in a triangle where all angles are 60 degrees, all sides are going to be the same. So we could go ahead and write that we have an A here and an A here as well. Okay, so at that point, what we're going to have to do is we're going to have to determine the area of that triangle in order to solve for A then. Okay, so the area of that triangle is going to be the area of the hexagon over 6 because there are 6 triangles. So we take that 384 root 3, and we split it over 6. So I'll plug that into my calculator real quick to simplify. 384 root 3 over 6. We see that that's going to be 64 root 3, 64 root 3. Okay, so that's the area of a triangle. So I've got that as my area of a triangle. I know my area of a triangle is 1/2 my base times my height. I know my base is A, right? Base is A right there. So it's going to be 1/2 A. Now what is my height going to be? Well, we know that our height in a triangle, I'm going to draw one right here that's bigger so you can see it, is this right here. That's H. Okay, if I know I have a 60 here, I know I have a 30 up top because we're splitting that 60-degree angle into 2. That gives me a 30, 60, 90 triangle, which I can use to solve for the height. So I know down here this side length is going to be 1/2, or A over 2, right? 1/2 of A, it's going to be A over 2. Well, I know then that this right here is going to be root 3 times whatever this length right here is, which in this case is A over 2. So it's going to be root 3 times A over 2, which is going to give me root 3, A root 3 over 2. Okay, so that's my height then. That is my height. Okay, so I take that height then, that A root 3 over 2, and I put that right here, times A root 3 over 2. Okay, so now I've got half A squared square root 3 over 2. Because we had half A, and then times A root 3 over 2, so that's going to be half A squared root 3 over 2. All right, so now what can I do? I can take this half here, I can simplify that by splitting it over 2. Okay, half over 2 gives me a quarter, so 1/4 then A squared root 3. Okay, 1/4 A squared root 3. That's a 4, not a 9. Okay, now I know that that's got to equal that 64 root 3. So I'll go ahead and multiply each side by 4 to get rid of this 1/4. Okay, so now we got 4 times 64 root 3. Next, I'll divide each side by the square root of 3, get rid of it here, get rid of it right here. Now I have A squared equals 4 times 64. Now, do I have to solve for A? Answer, no, I do not. Why? Because I'm asked for the area. Okay, I'm asked for the area of that square, which I know is A squared. So I don't even have to solve for A here. I just solve for A squared, which in this case is 4 times 64, which will give me 256. So my answer there is going to be answer choice A. Okay, so what can you learn from this? Well, for one, know when to stop. Okay, it's important to know when to stop when doing the SAT math section, because if you move on and you keep doing things and you solve for A, you're wasting time, and we don't want to waste time. So know when to stop. That's important. Okay, notice how I stated up top I wanted to solve for A squared. As soon as I got it, I stopped. I didn't solve for A. I only solved for what I needed to solve for. So that's a big thing with the SAT math section. There are some people who keep on solving even when they don't need to, and that's a waste of time, a waste of energy, and it's not efficient. So we don't do that. We stop when we need to stop. Okay, so we stop at A squared. 4 times 64 gives us 256. Okay, so questions 23 and 24 actually refer to a diagram above here. Right, we see that it tells us that it refers to it. We have a phase diagram for a substance. I see I have pressure on my y-axis, temperature on my x-axis, and then the different phases they're at based on those. So during mineral formation, the same chemical compound can become different minerals depending on the temperature and pressure at the time of formation. A phase diagram is a graph that shows the conditions needed to form each mineral. The graph above is a portion of the phase diagram for aluminosilitis. The temperature T in degrees Celsius on the horizontal axis and the pressure P in gigapascals on the vertical axis. All right, so let's take a look at our questions. We go down here. We got question 23. Okay, so they give me an equation. They say that this equation is the boundary line between Andalusite and Sillimanite regions, and it's approximated by the equation. What is the meaning of the t-intercept of this line? Okay, one thing we have to understand is for the t-intercept of this line. Okay, the way that you go wrong with this problem is you go wrong by thinking of the p-intercept. Okay, whenever we see an equation that looks like this, typically when we think of an intercept, we would think, oh, this is our intercept. Not in this case because we're asked for the t-intercept. Okay, the t-intercept in this case is going to be where p equals 0. Okay, where p equals 0 is where our t-intercept is. Okay, so the meaning of that has to do something with the pressure being 0. Okay, so let's look for an option that says something about our pressure being 0. So we have option A. It is the maximum temperature at which sillimanite can form. No, it's not the maximum temperature. Okay, that says nothing about pressure being 0. B, it is the temperature at which both andesite and sillimanite can form when there is no pressure applied. Okay, no pressure applied means pressure is 0. So yes, that's our correct answer, B. Okay, we have to include that there's no pressure, right? That's what it means. That's the temperature where it can be both andesite and sillimanite. Okay, either one could form when there's no pressure, right? No pressure, whatever this t-intercept is, that's going to be that temperature at which both can form because it's the boundary line. Okay, so answer there is going to be B. All right, so as far as tips you should put in your notes there, the big tip here is understanding that if we're asked for a t-intercept, right, or if we were asked for, say our equation said y equals mx plus b, the x-intercept, right, we need to understand that that means that that y would equal 0, okay? So we got to make sure we're paying attention to which intercept we're asked to find. Okay, so that's very, very important, is understanding which intercept we're looking at and which one we are interpreting the meaning of. Okay, if we were to do that incorrectly and look at this 1.11, we're going to get the wrong answer. Okay, so we have to make sure we're doing that correctly. So understand which intercept you're asked to interpret. In this case, that's going to be the one where there's no pressure applied, so my answer there is going to be B. Okay, we look at C, it says it is the increase in the number of degrees Celsius needed to remain on the boundary between andesite and sillimanite if the pressure is reduced by 1. No, that would be indicating something with slope. Okay, if we're reducing a pressure by 1 or something, that's indicating to me something with slope. D, it's the decrease in the number of gigapascals of pressure needed to remain on the boundary if the temperature is increased by 1 degree Celsius. Once again, that's dealing with a rate and that's dealing with a slope. So that's not going to be anything with intercepts. Okay, now we've got question 24. Okay, keep in mind it's also referring to that information in that phase diagram. So which of the following systems of inequalities best describes the region where sillimanite can form? Well, we have to go back up and find where sillimanite can form, come up with the equations for that. Okay, so let's go up. Let's find where sillimanite can form. I see sillimanite. In order for it to form, it's going to have to be greater than this line, and I'm going to pick a different color so you can see it more clearly. Okay, I'm going to draw it right along it. Okay, in order for sillimanite to form, it's got to be greater than this line in blue. Okay, so what is this line? Well, let's go ahead and draw a line up. One thing that we have to pay attention to here is we have a broken scale. Okay, we don't start at 0, we start at 400. So if we start at 400, and I guess I misused the word broken scale there, but you get what I'm saying. If we have 400 here, 500 here, we don't have 0 there. So our intercept isn't going to be at 0.6. It's going to be pretty much, we see we have 800 here, 400 here. We see that we went up by, let me switch back to my blue pen real quick. We see we went up from 800 to 400. We went up by from 0 to about 0.55, just about, right? So we're going to go up another 0.5 then, going from 400 to 0. So if we were to go all the way back here to 0, we're going to be right around 1.1, okay? So we're looking for something, y, has to be greater than or equal to 1.1 is our plus. Now we have a decreasing slope. That decreasing slope, we see we go down by 1.1 over about 800. So I'll put that in my calculator, negative 1.1 over 800, get our slope. Okay, we see that that's just about 0.00, looks like it's 137 after that. Let me just check, 1, 2, 3, 1, 2, 3, 4. So we got 3 zeros, 0.000, and then a 137x, right? So it'd be, I'll write that out bigger so you can see it. So we're gonna have to have a y is greater than or equal to a 0.1230, 1375x, and then plus 1.1. Okay, so let's just go ahead and check, find an answer choice that's got that. It's got to be something right along those lines. Okay, we see we have a couple with plus 1.1, so those ones are good. We can go ahead and get rid of A because nothing says it's got that plus right around 1.1 there. Now we know it has to be greater than that, so we can go ahead and get rid of this option here with D because it says P is less than that. We know P has to be greater than that. That leaves us with option C and option B, which both have them being greater than, so that one right there is taken care of. Now we look at B, now we look at this equation right here. So what does it have to be less than, right? Let's go up, take a look at that line. We see that line, if we were to go all the way over, right, we see from 800, if we go up here to 800, it's at about 0.8, and then we see at 400, it's at 0. So it's going down by just about 0.8 for every 400. So if we go 400 more over to 0, we're going to go down another 0.8 from where it was at 400, which we see if we were to continue that line. I'm going to put it in red so you can see the line different, right? So we've got this line here in red. If we were to continue that at 400, we're at about 0.2. We're dropping. We went from 800, we were at 0.8 down to 0.2 here. So that's a drop of 0.6. So we're going to drop another 0.6 and we're going to be at just about negative 0.4 when we hit that 0. So we're going to look for something that has negative 0.4 or something along those lines. I see neither one does, so that doesn't really help me there. So I'm going to have to find what error I just made, right? We know that P is going to have to be less than that, so we can't get rid of anything based on that. Really what we're looking to determine here then is that y-intercept. So it looks like I made an error here. Let's go back and find what I did wrong. Okay, we see at 800 we are at just about 0.85, and we see at 400 here, if we were to continue this line, we're going to probably be maybe just below that 0.2, so maybe 0.15. Okay, so 0.85 minus 0.15. So 0.85 minus 0.15. Okay, I see what I did wrong. So we see we dropped by about 0.7 or 0.6. I started at 0 here. That's where I made my mistake. I need to start from this right around 0.2. When I do that 0.2, then minus that, or 0.15 minus that 0.7 change, that gives me negative 0.55. I go down here, find my answer that's closest to that. I see that that's going to be closest to B, so my answer for 24 there is going to be B, right? So that one right there, that one's a little bit tricky. You had to make sure that you were really paying attention to your graphs and your changes. Another way that you could have solved for this one right here is to find the slope, and that's actually probably would have been the more efficient way to do it, so I actually probably should have done that, because finding that slope makes it so I don't have to guess as much going off of that graph, right? If I solve for the slope there, that probably would have been an easier way to do it. But either way, we get to the answer B, so B will be our correct answer there. So that one right there, big tips are annotating your graphs. I always recommend to annotate your graphs, right? You see all the markings I made up. Annotating your graphs helps you to not make a visual error, so that's always good. And then as far as other tips, yeah, it's really just understanding these inequalities, right? We knew that P had to be greater than that line. That was, I'll scroll back up and show you. Okay, we know in order to be Solomonite, I'm going to erase some of this. We knew we had to be greater than this line right here. We had to be greater than that to be in this region, but we had to be less than this line up here to be in this region. So it was really understanding that. Once you got that, you were all good to go. All right, now we got question 25. Okay, question 25 is giving us two equations. So we're asked for the system of equations above, it's graphed in the xy plane, which of the following points do the graphs of the equations intersect? Okay, they're going to intersect when they're equal. One thing that I see right away is that they both have y equals, so I'm just going to set them equal to each other. So we're going to have 2x plus 4 equals this right here. At this point, I'm going to go ahead and multiply this out, right? So I'm going to go ahead and do the FOIL method, right? So we're going to have x times x, it's going to give us x squared. Negative 3 times x gives us minus 3x. And then we have a 2 times an x gives us plus 2x. Then we have a 2 times a negative 3 gives us minus 6. Okay, we know that that's all equal to 2x plus 4. Now we're just going to set it equal to 0. Okay, so we subtract 2x, get rid of that, and subtract 4 here. Subtract 2x, and then subtract 4. So negative 6 minus 4 gives me negative 10. Negative 3x, and then I see I have plus 2x and minus 2x. Those will cancel out. So I'll be left with x squared minus 3x minus 10 equals 0. At this point, I factor it to solve for what my possible solutions are. So I factor that out. I see I'm going to have, I'm looking for things that multiply to get negative 10 but add to negative 3. I know that that's going to be x minus 5 and then an x plus 2. Okay, so those are my factors there, which means that x could equal 5, or x could equal 2, or they both could be solutions. Or I'm sorry, x could equal negative 2, right? Since this is positive 2, it could be negative 2. All right, so now I'm going to take a look. We'll just deal with 5 first. So we're going to plug 5 in, see if they equal each other. Also, I see, actually, I know that I can't use negative 2 because it's not even in my answer choices. So I know I have to start with 5. Okay, so that's one thing there, is paying attention to your answer choices. If I would have plugged in negative 2, I would have wasted my time. I want to plug in 5 because that's my only option here. So I plug in 5. I got 5 times 2, that's going to give me 10. 10 plus 4 is going to give me 14. I know that that's going to have to be my answer because my other option isn't even included here, right? So 5 and 14 would have to be my answer. I'll go ahead and show you how that's true, though, by plugging in down here as well. If we plug in 5 right here, we have 5 minus 3. 5 minus 3 gives me 2. So then I got 2. 5 plus 2 is 7. 2 times 7 also is 14. Okay, so answer there is going to be D. So that one right there is really just algebra. Set your equations equal, and then bring all your x's to one side, set it equal to 0, factor it, find your solutions, and then pay attention to your answer choices so you don't waste time plugging in a solution that isn't there, right? The negative 2 right there, that's not an option, so we don't plug that in. Okay, the gas mileage ms in miles per gallon of a car traveling s miles per hour is modeled by the function below. We know s has to be between those two numbers. Now we're given m of s. According to the model, at what speed miles per hour does the car obtain its greatest gas mileage? All right, one thing you need to understand, if we have this negative in front of this s squared, we know our graph is going to look something like this, right? Because it's going to be a downward sloping parabola since we have a negative in front of our s squared. So it's going to be a downward sloping parabola. It's going to have a maximum somewhere. So there's two ways you can do this. If you have a graphing calculator, one way you can do it is you can just plug this in to your graphing calculator and calculate the maximum. Okay, so to do that, I'm going to explain that to you real quick, and then after that I'm going to tell you the quickest way to do it, which is actually not using your graphing calculator, but it might be difficult for some of you guys to remember how to do it without a graphing calculator, which is why I'm going to quickly explain how you would do it on a graphing calculator. Also, it's always good to know that other way just in case you forget the quicker way. Okay, so we've got what you're going to put in your calculator then is obviously this equation. So you'd press the y equals button if you're using a TI-84 or a TI-83. You plug in this equation here, you use x instead of s, right? You just use x instead of s, it's not a big deal. And then after that, you'd press the graph button. After that, you'd press second and then trace. Then you would press maximum, which on my calculator is 4. So you'd press maximum, and then you would press enter with it being left bound, go to the right till it's past that maximum, press enter again, and then press enter a third time, and then it will tell you where your maximum takes place, which it'll tell you is at 48, right? So we know S would equal 48. We know our answer there would be B for number 26. Okay, another thing to pay attention to is it's asking you at what speed. Okay, so that's S. Okay, so we're solving for X here, not MS. So we wouldn't answer 46, we would answer 48 because that's what our S is when this maximum miles per gallon is, right? Okay, so now that's the way you solve it with a graphing calculator if you would like to, but a faster way to solve it actually involves calculus. So the reason that I didn't start with that method is just because it's going to be possibly a little bit hard to grasp for some of you, so I wanted to start by showing you how you could do it with a graphing calculator. But now that I've done that, I'm going to show you the faster way to do it. Okay, this is much, much quicker. This is the way I would do it if I were taking the SAT. This is the way I'd recommend you do it as well. But I wanted to show you that other way with the graphing calculator just in case you forget to do this. Okay. So if we're asked, right, I already showed you that it's going to be a peak like this, right? We're going to have our maximum right here. So if I know that and I know I have to solve for that maximum, what I can do is I can do something called taking the derivative. Okay, so that's something you learn in calculus. If you have not learned about taking the derivative, I'm going to show it to you now. So what we're going to do here in order to find that maximum is we're going to take this squared value, we're going to multiply it by this 1 over 24. Okay, and then we're going to take the squared value, we're going to subtract 1 from it, so it's 2 minus 1, which will just leave us with s. Then we take that first power right here on this s, multiply it by that 4, which just gives us plus 4, right? And then this s, we take that power it was at, we subtract 1, and now that s is gone. Okay, so now we just have plus 4, and then if there's a constant like this, a negative 50, plus 1, minus 1, whatever it is, we ignore it. Okay, then we set it equal to 0. So what we'd have here is we'd have 0 equals negative 2 over 24, which is the same as negative 1 over 12. 1 over 12. Now we still have an s here, okay, and then we have plus 4. Okay, at that point we'd go ahead and add 1/12 s to each side. We add 1/12 s to each side, set it equal to 4. Then we have to multiply each side by 12 to get s alone, and we see 4 times 12 gives us 48. Okay, in my opinion, that's the fastest way to do it. Okay, I think taking that time and plugging it into your calculator like that, unless you're really, really quick at typing it into your calculator, this is going to be the fastest way for you to get to your answer, so that's the way I would recommend doing it. But I wanted to show you both ways just in case you weren't comfortable using calculus yet and finding the derivative. Then you can still use your calculator to find the answer. But if you are comfortable with calculus, that's going to be the fastest way to answer it. Okay, so if you're comfortable taking the derivative like that, that's the way I recommend. I don't think I've ever taught taking the derivative yet in this course. So I would write that down in your notes if that's something you want to use. That's something I would recommend writing in your notes just in case you ever do have to use it. Just in case maybe it showed up on the math no calculator section. I don't think I've ever seen a question with derivatives show up on that in my opinion. But I think it could be possible. I don't know for sure. But I would just recommend possibly putting this in your notes if you want to learn how to take derivatives. This is a really simple example. I don't think they'd ever give you some complex example of taking a derivative. I've never seen it. This is about as complex as I think I'd ever see it get, right? And keep in mind also, like, you don't necessarily need to know how to take the derivative. You could solve it using a graphing calculator. That's fine. So either way, whichever one you want to do, you can put either one in your notes. But I would recommend at least putting in this taking the derivative in your notes, just in case at some point you want to use it. But it's your call on that. So with that, we'll move on from 26. 26 answer was B, right? 48. That's how we got it both ways. Now we can go ahead and move on to 27. All right, now we got 27. So we got a table here. It's showing selected values for our function h in the xy plane. We got y equals h of x as a line. What's the value of h of 8? All right, well, I see that since it's a line, it's going to have that same slope, right? So we go from 2 to 4. That means we're going up 2 on our x, and we see we go up 4 in our y, okay? So if I go up another 2, then I'm at 6, and if I go up another 2, then I'm at 8. Okay, so then I've got to go up another 4. That puts me at 15. Go up another 4. That puts me at 19. My answer is going to be 19 at 8. Okay, so that one right there, that one's pretty simple. Not too bad at all. Just one thing to note, notice how I annotate my table. That's something you can use as well. That's something that can prevent you from making a silly mistake. So if you want to do that when you take the SAT and practice test, that's something I would recommend as well. Okay, so that one right there, that's pretty simple. That one's just understanding a line has the same slope, and then we're just increasing by 2 until we get to 8, finding what y equals at that point. That's 19. Okay, so that one right there, pretty simple. 27, answer there is B. All right, 28. Front row of an auditorium has 10 seats. There are 50 rows in total. If each row has 2 more seats than the row before it, which expression gives the total number of seats in the last row? All right, well, our first row, right, that has 10 seats. Okay, now we know each row after that is going to have 2 more for a total of 49 more rows after that. Now, why is it 49 more rows or 50 minus 1? Well, we know there's 50 rows in total, and our first one has 10. We can't count our first one twice, so we have to subtract that first row that we have by doing that minus 1. Okay, so answer there is going to be A. All right, as far as why we know the other answer choices are wrong, I want to show you that real quick as well. Okay, we know 2 to the power of 50 is wrong because that would be exponential growth. Okay, if we're raising it to a power, that's going to be exponential growth, and we know it's linear because each row is gaining 2 more seats than the row before, so that's linear growth. Okay, the other thing that we see in C to make C wrong is that we have 50 times 10 plus 2. Okay, this one really is kind of a really wacky answer. I don't know how you'd really get to this unless you thought 50 was the amount of rows we were starting with, and we don't want to do that, okay? So we aren't starting with 50. This one really is just way off. As far as B, B would be just if you forgot to subtract your first row, okay? B was the answer that you would get to be wrong if you forgot to subtract that first row you start with, okay? So answer for 28 there is going to be A. So that one right there is just making sure you remember that you start with 1 row, so you subtract that from the amount that you're multiplying by. All right, now we've got 49. An ecologist selected a random sample of 30 prairie dogs from a colony. Okay, random sample means I can apply it to that whole colony since it's a random sample, and found that the mean mass of the prairie dogs in the sample was 0.94 kilograms, with an associated margin of error of 0.112 kilograms. Which of the following is the best interpretation of the findings? All right, as far as margin of error goes, anytime I see a margin of error question dealing with a mean, immediately what I'm thinking for my answer, right, is going to be something talking about how my possible values for my mean of that colony then is going to be somewhere from 0.94 minus 0.12, right, which is going to give me 0.82, all the way to 0.94 plus 0.12, because margin of error works both ways. So I have to add it to the mean and subtract it to the mean to get possible answers for what my mean could be, right? So 0.94 plus 0.12 is going to give me 1.06. Okay, so I'm looking at any answer between those. Okay, now I can't apply it to all prairie dogs because it was from one single colony. Okay, so I can't say A is correct. Also, it says all sample prairie dogs in the sample have a mass between that. No. Okay, those are possible values for the mean. Okay, we can't say all of them will have that mass. That's for the mean. So A is incorrect. B, most prairie dogs in the colony have a mass between 0.82 and 1.06. Once again, that's wrong because we're talking about the mean. Okay, the mean could be anywhere between these two numbers. Okay, so it's not going to be that most prairie dogs are between it. It's going to be that the mean could be between those. So B is wrong. C, any mass between 0.82 and 1.06 is a plausible value for the mean mass of the prairie dogs in the sample. Okay, why is this one wrong? Well, we're asked for the best interpretation of these findings. The best interpretation of these findings will apply them to the colony as a whole because that's what that random sample was selected to represent. Okay, that random sample is supposed to represent this colony as a whole. So we want to apply that mean to the colony. Okay, not the sample. So C is incorrect. So our answer there is going to be D. Any mass between 0.82 kilograms and 1.06 kilograms is a plausible value for the mean mass of the prairie dogs in the colony. Okay, we want to apply that data or interpret that data to where we took that sample from, which was that full colony. So our answer for 29 there is going to be D. Okay, that one right there is really dealing with data. Okay, that one's understanding how to work with it, right? That's kind of a statistics question. Now we got 30. A poster has an area of 432 inches. The length x in inches of the poster is 6 inches longer than the width of the poster. Okay, so the width is going to equal the length minus 6 then. Which of the following equations can be solved to determine the length in inches of the poster? Well, we know length is x, right? And we know that width is 6 inches less than x because the length, which is x, is 6 inches longer than the width. So the width is going to equal our length, which is x, minus that 6. And we know our x is going to equal our length. We know length times width gives us area. Therefore, we know that 432 is going to equal our length, x, times our width, x minus 6, right? And we know that when we go ahead and multiply that out, we have an x times an x giving us x squared, and then we have an x times a negative 6 giving us minus 6x, right? And that's going to equal that 432. Okay, so our answer there then is not going to be A because we need minus 6x. It will be B. All right, also make sure to like, share, and subscribe, but that's on another note. All right, question 24. So in the xy plane, the graph of a linear equation of the form y equals mx plus b and the graph of an exponential equation of the form y equals ab to the power of x both contain points 1, 3, and 2, 4. If the point rs is on the graph in the linear equation and the point rt is on the graph of the exponential equation, where 0 is less than r and r is less than 4 and s is greater than t, which of the following must be true? Okay, so at first this might overwhelm you, and that's understandable. But one thing we can do when we have a lot of points like this and we feel overwhelmed and we don't know where to go is we can make a graph. Okay, so in this case, I see I have 2 points, right, or 2 equations. I have one that's linear and I have one that's exponential. So what do I know about linear versus exponential? Okay, let's go ahead and make a quick chart of what we got here. Okay, we know that they both contain points 1, 3, and 2, 4. So let's plot those points down. We got 1, we'll put 1 here, we'll put 2 here. We'll say 3 is here, and we'll say 4 is up here. Okay, so we got 0.13, and we got 0.24. Okay, so we got 0.24 there. Okay, well, what do we know about this linear equation? Well, we know it's linear, right? So we know it's going to go like this. Okay, let's go ahead and draw that. We know it's a line, so it's going to look something like that. Okay, now what do we know about this exponential equation? Well, we know it has these 2 points, right? It's got a point at 1, 3, and 2, 4. We also know exponential equations, they go like this, right? They get exponentially greater, right? They have an increasing slope like that. Okay, so it's going to look something like that. Now, keep in mind then, I have these points here. Each one has that same x value, okay? And then they have different s and different t, okay? So s is the one for the linear, t is the one for the exponential. Now I'm asked for where s is greater than t. Well, where do I see s is greater than t? S is that y part. I see it's greater than t between this 1 and 2, but I know after 2, t would be greater, okay? And I know anything before 1 and t would probably start moving up, right? But I know for sure between 1 and 2, I know for a fact that this s, this linear part, this linear y, is going to be greater than that t. Okay, so my answer there has to be B, between 1 and 2. Okay, notice how easy that was when we graphed it out. So in certain situations, if you're given a situation where you have lots and lots of points, right? In this case, look at how many pairs of points we have. Okay, see how we have 4? I'm going to look to do one of 2 things, right? And I have 2 equations here. Now, what I'm going to look to do is one of 2 things, okay? Either I'm going to look to do something with the slope, because if I'm given 4 pairs of points, that's an indication to me that maybe I have to do something with the slope and finding something that's parallel or perpendicular. But in this case, I wasn't asked anything about being parallel or perpendicular, so I knew it probably wasn't going to necessarily have to do something with slope. So then I started graphing it because I saw that I had one that was linear, one that was exponential, right? And I'm asked for where one y value is greater than the other, and I already had a pair of points where they each intersected. Okay, so by drawing that out in that graph, I was able to quickly see the fact that this s had to be greater than that t between that 1 and that 2. Okay, so graphing a situation like this can be very, very helpful and make things a lot easier. So answer for 24 there is going to be B. All right, now we've got question 25, so let's go down and see what that's got to say. All right, I see I've got a table. I'm told 2 independent surveys asked random samples of 500 people about the distance they commute to work each day. The results of the surveys are detailed in the table below. So we have a daily commuting distance, 2 different surveys. We got their mean distance in miles. We got standard deviation in miles. Okay, one thing that jumps out to me right away is standard deviation is the same. Which statement's the true based on these surveys? So let's go ahead and run through our options. If we're asked for what's true about these surveys, we basically have no choice but to go A through D till we find one that's true. A, there is greater variation in the distribution of the distances people commute to work in survey A. Well, no, we know that their deviation is the same, right? They have different means, but their standard deviation is the same. Okay, so deviation is going to be the same. One isn't going to be different than the other. Option B, there's greater variation in the distribution of distances people commute to work in survey B. Also not true. Okay, we know they have the same distribution, or I'm sorry, not the same. The same variation, right? They have the same variation. There's not greater variation in one than the other. Okay, C, the variation in the distribution of the distances people commute is the same in both surveys. Yes. Okay, we know that that's true. That standard deviation is the same. Therefore, the variation and that distribution of the distances that they commute is going to be the same. Okay. Standard deviation is a measure of that variation from the mean. Okay, so we know the variation in that distribution of the distances they commute is going to be the same in both surveys because that standard deviation is the same. Okay, so C will be our correct answer for 25. Why is well, we're going to cover why D is wrong as well here. D says it's impossible to determine the variation in the distribution of distances people commute because the means are different. No, we can still determine that variation by using that standard deviation with the mean, okay? With the different means, it still works. So D is incorrect there. C is our correct answer there. So C, really what you want to take from this is that standard deviation tells us that that variation in the distribution of those two things is going to be the same because they have that same standard deviation. Okay, 26. During an ice age, the average annual global temperature was at least, okay, that's a key word there. Anytime we see something like at least or at most or anything like that, that's telling us that we're going to have an equal sign, right? Some sort of inequality with an equal sign below it. So we know that the average annual global temperature is at least 4 degrees Celsius lower than the modern average. If the average annual temperature of an ice age is y degrees, okay, y degrees is this ice age temperature, and the modern annual average temperature is x degrees, which of the following must be true? Well, our average annual temperature when it's not an ice age is x. We know that when it is an ice age, it's 4 degrees less than that or more, okay, or more. So we know then that our y is going to have to be it's going to have to be less than that x minus 4, right? Or I guess, hang on a minute, let me just quick check something. This is 26. We know that, yes, we know that x minus 4, right, is going to have to be greater than y because whatever this average annual temperature is, right, whatever it is, let's say that it was an average of 73, okay? Let's say we had 73 minus 4 must be greater than whatever y is, right? Y would have to be 69 or less, okay? So it would have to be something like 68, 67, 62, something like that. But that's really telling us that that's going to be our situation there, right? And notice how I was hesitant there for a minute. If you ever find yourself hesitant with an inequalities problem like that, you can just check it with real numbers as I did there, okay? So anytime you're hesitant with an inequality problem like that, just go ahead and check your numbers. Just make sure it works out just like I did there, okay? So that tells us that then D will be our answer for 26, okay? Because that's what matches our equation. If we were to put y over on the left side, it would just be the same, right? We'd have y is less than or equal to x minus 4, okay? So that one right there, not too bad at all. Just understanding inequalities, making sure we're paying attention to the word at least. Because if we didn't pay attention to at least and we just thought equals, we'd answer A and that would be incorrect. So it's important to pay attention to words like those. All right, with that, we go ahead and move on. We've got question 27 now. Okay, 27 is on that next page. Okay, I see I got a big graph. All right, in the XY plane, line M is perpendicular to line L. Line L is not shown. Okay, line M is. So line M is perpendicular to line L, which of the following could be an equation of line L? Okay, what I know is line L is perpendicular to line M. Okay, so I can just, since it doesn't give me points for line L, I can just make them up. So I can just pick wherever. We'll just pick right here, right? So we need it to form a 90-degree angle. So what I'm going to do is I'm going to find the slope of line M. So I see that I rise 3 for every 5 I run over. So my slope then for M is 3/5. So now I need to take the opposite reciprocal in order to find my slope of L. So the slope of L, right, we'll do slope L, is going to have to flip the sign. So we had positive for line M, so we're going to have negative. And then flip my denominator to my numerator and my numerator to my denominator. Okay, so then it's going to be minus 5/3. Okay, minus 5 over 3. So that's what my slope has to be. Now, what do we see here? We see that we have no equation that's in y equals mx plus b form. Okay, what should we do? Well, the first thing we should do is not panic. Okay, we can easily find the slope from something like this. It's not a problem. It's very, very simple. Okay, so what we're going to do is we're going to flip the sign of whatever our x value is. So in A, I see it's 5x. What I'm going to do is I'm going to flip that sign. So I'm going to say negative 5. Okay, and then after that, I divide by whatever my coefficient from my y variable is. I see that that's 3 there. So I divide by 3. That's my slope for that equation. I see that slope is negative 5 over 3, which is equal to my slope for L. So A will be my correct answer. Okay, so as far as things you should put in your notes here, one thing that you could put down that could be certainly helpful, and that would be certainly helpful on the SAT, is understanding how to get the slope from an equation set up like this. Okay, if you have an equation set up like that, what you're going to do is you're going to take the negative of whatever the coefficient of x is. Okay, so in this case it's 5, so we would have negative 5. Now if it were negative 5, we would have negative 5, which would make it positive 5. Okay, but in this case it's 5, so we take the negative of that gives us negative 5. Okay, then we divide that by whatever the coefficient of y is. Coefficient of y. Okay, now if the coefficient of y, in this case is 3, is positive like that, then we just divide by 3. Now if the coefficient in front of y was negative 3, as it is in B, then we would have to divide by negative 3. Okay, so just understand that. Okay, we include the sign we include that sign when we're dividing by those coefficients. Okay? All right, and that's going to give us our slope, right? That's going to give us our slope, but keep in mind that that's only for this form, okay? That's only for the form where the x and the y are on the same side like that, okay? So that's specific to an equation written like this, okay? So if you're going to put this in your notes, make sure that you put that it's only for the equations that aren't in slope-intercept form, right? It's only for when those x's and y's are on the same side like that, okay? If you're looking for your slope and your equation looks like this, y equals mx plus b, your slope is just m. Okay, so this is only for finding the slope when you have x and y on the same side. Okay, so that one right there, certainly not too rough of a problem. Once you understand how to get that slope, it becomes very, very easy. All right, now we got 28, so we got a maximum speed versus maximum height of 12 roller coasters. I see I have a line of best fit, speed on y-axis, height on x-axis. So the scatter plot above is showing my maximum height in feet and maximum speed, s in miles per hour, of 12 roller coasters, as well as the line of best fit for the data of the following, which best represents an equation for the line of best fit. Okay, all right, so where is this trying to trick you, right? Where is it trying to trick you, okay? Obviously, it's right here, okay? If you didn't see that, that's okay. I'm teaching it to you right now. Anytime I'm looking at a graph and I'm asked to find an equation of line of best fit, or asked about an intercept, or asked to make an equation of a line, anything like that, immediately, the thing that I'm always watching out for is what this x-axis is starting at, okay? Because if it's not starting at 0, then my intercept can't be this right here at 62. Okay, because that's not where it equals 0. So in order for me to find what that intercept's going to be, what I'm going to do is I'm going to take whatever distance it is till I get to 0. In this case, I see it's 140 till I get to 0. I'm going to move 140 to my right then. I see that that's going to get me 280 right here. I'm going to draw a line up. Okay, I see that that line, if I extend it over, is at about 92. Okay, if I draw a line from this 140, I see it's at about 62. Okay, so I got 92 then minus 62 is how much I rose, which I see is equal to 30, okay? And I rose that 30 over 140, okay? So now if I want to find my intercept at 0, right, I have to subtract another 30 for every 140. So I go 140 to my left, I got to subtract 30 from 62, and that's going to leave me with 32. Okay, so my intercept is going to be positive 32, so I can get rid of C and D. I know I have positive 32. I check to see if my slope can give me my answer. I see that I'm going to have to actually find it, because I can't just tell by the sign and the direction of my line. So I actually have to find my slope. I see that my slope here, right? I see I'm increasing by 30 for every 140, so I'll plug that in my calculator. 30 over 140, that's going to give me my slope, and I see that that's 0.21. Okay, 0.21, so my answer there is going to be A. All right, so as far as things to understand for that, so that's 28, answer there is A, things to understand. Okay, notice how efficient this was. Okay, by me finding this intercept, using this equation here, right, finding that rise over run for that 140, not only was I able to find my intercept very, very quickly, but I was also able to then, after finding that intercept, use that same equation to find my slope. Okay, so by setting it up like that, and not using two different things, not trying to find the slope by using like something like this, I'm going to put it in blue so you can see it better. Okay, by not trying to find the slope with something like this, okay, and then also finding then that y-intercept based on that slope from that narrow thing right there, by not doing that and by looking big picture, right, from here, I'm going to put it in red so you can see it instead of blue. By looking from here all the way up, down, and then over to 140, I'm able to get a more accurate slope, but also I'm able to go ahead and find then what my intercept is very, very easily, okay? So that's a strategy I use. That's a strategy I recommend you use. Also notice how I'm annotating my graph. I recommend doing that so you don't make a simple mistake, okay? It helps us prevent mistakes that's just from poor eyesight or poor vision by making sure we're drawing those lines. So that's something I recommend doing. All right, now we have Selena created a scale model of an airplane where 1 centimeter equals 6 meters on the airplane. The wingspan of the model is 10.7 centimeters. Selena wants to make a new model where a scale of 1 centimeter on the model equals 3 meters on the airplane. Which of the following best describes how the wingspan of the new model will compare to the wingspan of the first model? All right, well, if 1 centimeter is representing 3 meters, so it's representing less meters on this new model, okay? If we're representing less meters on the new model, then this new model is going to have to be bigger, right? Because if we have 1 centimeter representing 6 meters in our first model, and it's 10.7 centimeters, then we could do 10.7 cm times 6m per cm, 6 meters per centimeter. We cancel out our units, and we have 10.7 times 6, which will give me something right around, it'll give me something right around 64. I'm not going to put it in my calculator because I don't need to, right? I'm not going to waste time doing that. So I see that's going to give me something right around 64 meters is the actual height of the plane. Well, now in my new one, if I want it to be 3 meters for each centimeter that it is on the model, then I would take that 64, I'd divide it by 3, and that's going to give me something that's much larger than that 10 centimeters, right? That's going to give me something that's right around 21, okay? 21.4 or something, okay? So that's going to give me something that's just about double, right? Which makes sense because we're doubling that scale, right? We're going from it representing 6 to 3, right? Which means it's going to have to represent, it's going to have to be larger, right? Since it's representing less of that airplane per every centimeter. Okay, so we know that that's going to be a double, right? So let's find the answer that says a double. We have A, the wingspan of the new model will be 3 centimeters shorter. No. B, the wingspan of the new model will be 3 centimeters longer. No. Okay, those two would be really, really bad answer choices because we know we're looking at a rate problem here. Okay, C, the wingspan of the new model will be half as long as the wingspan of the first model. No, I just showed you it has to be 2 times as long as the wingspan. All right, so some of you may be thinking, why did he take the time to write out that ratio? I knew immediately that it was going to have to be double the size because it's representing half of the size that it was previously. And since it's representing half the size it was previously for every centimeter, it has to be double as big. Well, here's the thing. Sometimes doing that in your head is going to make you get it wrong. Okay, most of the time you'll be good. But here's the thing. If I see a question that's 29 on the SAT Math with Calculator section, it's probably 29 for a reason. And it's probably 29 because people are going to mess it up. Okay, those ones that are really late in the SAT Math section, they're designed to be tricky. Okay, and now if you try to do that in your head, the problem is you could end up answering C. Okay, you would probably recognize it's a ratio question, which is correct. It is a ratio question, but it's possible you'll mess up the ratio in your head. So with questions that are 29 and 30, you've got to be very, very careful. Okay, so when you get to questions really past 25 or past 23, you got to make sure you're paying close attention to the details because otherwise you might end up answering C here and C is incorrect. So as far as why I went ahead and wrote it out, I wrote it out because if we're dealing with a question at 29, we want to be careful, which means we're going to want to make sure we're using units to cancel, right? So I used my centimeters, I canceled those to get my thing in meters, then I divided by how many meters I had per centimeter, right, to get my answer in centimeters over here for my new model, okay? So if we're dealing with questions on 29 and 30, we just got to make sure we're paying close attention to detail, right? And we want to check our answers if we have time, okay? So I'm not saying you check your answer immediately, right? I would recommend, obviously, that you go through, answer all your questions first before you start going back and checking your answers. But when you go back and check your answer, you're going to want to write it out, make sure you cancel units, that way you can make sure you're getting this right? Also, if you weren't really sure where to go with this, you can use canceling units to find out where you're going if you didn't immediately recognize that ratio right off the bat. Okay, so hopefully that was helpful. Really, I'm just trying to stress with that, if you got a question on 29 or 30, just be careful because they're going to be tricky questions. So if it seems easier than it should be, just make sure that you're making the right ratio. All right, 30, Hongbo sold X cell phones in 2013. The number of cell phones he sold in 2014 was 128% greater than in 2013. And the number of cell phones he sold in 2015 was 29% greater than those in 2014. Which of the following represents the number of cell phones he sold in 2015? All right, well, 128% increase, right, versus 2013, that means that it's going to be 2.28 times whatever he sold in 2013. Now, why is it not 1.28? Well, 1.28 would be a 28% increase. 128% increase means that it's more than double, right? So that's going to be 2.28. So that's 2.28 times whatever he sold in 2013, which we know is X. Now after that, we see in 2015, he sells 29% more than he sold in 2014. So there we multiply by 1.29. So our answer then is going to be answer choice D. Okay, so that one right there, that one's not too bad. That one right there, I'm kind of surprised it's at 30 given the ease with which that one is possible to solve. The reason that it's probably at 30 in my opinion is this right here, this 128%. Okay, some people would see that and just write 1.28. Okay, so that's what I say about being careful with these 29 and 30s and anything past 23 is just make sure that you're paying attention to details, not making simple mistakes. All right. The relationship between the monthly rental price R in dollars and the property's purchase price in thousands of dollars can be represented by a linear function. Which of the following functions represents the relationship? All right, well, I'm told my purchase price is in thousands of dollars, right? But my rental is just in dollars. So I got to get rid of these thousands here so that way I don't mess up my units. So now when I do that, I see I have to find the slope, right? Well, my slope's going to be my rise over run, right? Or my Y value, which is RP, over my x value, right? My increase in y over my increase in x. So when I do that 950, right? I'm just going to pick one and I'm going to use it. So I'll pick that 950, that Clearwater Lane, and I'm going to divide it by that 128 to get my slope. When I do that, I get 7.4, which is closest to 7.5, right? So I'm looking at D as my answer choice, and I check that to make sure my y-intercept doesn't mess with it real quick. So I put in 950 should equal 7.5 times 128, and 7.5 times 128 is equal to 960. 960 minus 10 is equal to 950. I know that's my answer. So now I move on. Question 24. Townsend Realty purchased the Glenview Street property and received a 40% discount off the original price, along with an additional 20% off the discounted price for purchasing the property in cash. Which of the following best approximates the original price in dollars of the Glenview Street property? All right, well, we know our original price times 0.6, right, because we got 40% discount off the original price. That's going to give us our discount price, which then received 20% off of that. 20% off of that means we're going to multiply by 0.08 to give us our purchase price, which we are told in that graph, Glenview Street, our purchase price was $140,000. All right, so I'm going to move this over so we can see this. So we got $140,000. So now what I'm going to do is I'm going to manipulate this to solve for my original price. So when I do that, I have to divide by 0.6, and I got to also divide by 0.8. So I do that. I divide this side by 0.8 and 0.6. So now I'm going to plug that into my calculator here, and we will see what I get. So I got 140,000 divided by 0.8 in parentheses times 0.6 end parentheses, right? I do that, and I get 291,000 and about 700. So my answer there is going to be B. All right, question 25. Make sure I answered all those. I did. All right, question 25. A psychologist set up an experiment to study the tendency of a person to select the first item when presented with a series. In the experiment, 300 people were presented with a set of 5 pictures arranged in random order. Each person was asked to choose the most appealing picture. Of the first 150 participants, 36 chose the first picture in the set. Among the remaining 150 participants, P people chose the first picture in the set. If more than 20% of all participants chose the first picture in the set, which of the following inequalities best describes possible values of P? All right, well, we know that P plus 36 then, right? P plus 36 is going to be my total amount that picked it, and that has to be greater than our 20% of our total, which is 300. So we got 20% represented by 0.2 times 300, and we know our total amount of people who picked it is P plus 36, and it has to be greater than that. So we know our answer there is going to be D. And we also know P has to be less than or equal to 150, because that's all the participants that were participating in that second trial run there. All right, the surface area of a cube is 6 times quantity A over 4 squared, where A is a positive constant. Which of the following gives the perimeter of one face of the cube? All right, well, surface area, right, SA, that's equal to 6 times the area of each side. Well, that means that my area of each side then is going to be my A over 4 squared. So I've got my A over 4 squared, right? That's my area, and we know my area then for a cube, right? For that side, the side of a square is S squared. I root that to get my side length, right? So my side length is going to be A over 4. And now I'm asked for my perimeter. I can use that side length then to find the perimeter because all the sides are the same. So I'm going to have 4 sides times my A over 4 is going to give me my perimeter. Right, so my perimeter of one face of the cube, I got 4 times A over 4. My 4's will cancel, and I'm left with A. So my answer is going to be B. Question 27. The mean score of 8 players in a basketball game was 14.5 points. Right, so I got 14.5. It's going to equal my total over my 8 players. And now, if the highest individual score is removed, the mean score of the remaining 7 players becomes 12 points. What was the highest score? All right, so 7 players, they scored an average of 12 points. So their total, I'm going to call TOT, total. So I'm going to multiply 7 by 12 to get my total there. Right, so that gives me 84. Right, so I know my total there is going to be 84. Well, going back up here, I know that 84 of those 7 players, plus my 8th players, which I'll call B, just to give me a value for it, right? That 8th player then scored B points. So now what I'm going to do is I'm going to multiply 8 by 14.5, and then I'm going to minus that 84 to solve for B. So I'm going to do 8 times 14.5 in my calculator. Right, that gives me 116. Now I subtract 84 from each side, right? So I've got 116 minus 84, and I know that that is going to leave me with 32. So my answer there is going to be C. All right, moving on. Question 28. The graph of the linear function f is shown in the xy plane. The slope of the graph of the linear function g is 4 times the slope of the graph of f. All right, well, my slope for my function y equals f of x, I see I run 2, I rise 1, so my slope then is 1/2. I'm told that my function g of x, its slope is 4 times 1.5. 4 times 1.5 is 2, so I'll have 2x, and it passes through the point 0, -4, so that means my y-intercept's -4, so I'll have 2x minus 4 as my equation. What's the value of g of 9? That's going to be 2 times 9 minus 4. I know that 2 times 9 is equal to 18, and I know 18 minus 4 is equal to 14. My answer is going to be 14, C. All right, question 29. The equation above defines a circle in the xy plane. What are the coordinates of the center of the circle? All right, well, if our center point is hk, we know the equation of a circle is going to be x minus h squared plus y minus k squared equals r squared. So when I look at my values here, I see I have x squared plus 20x. Well, in order to get plus 20x with x minus h, right, I know that I have to have then x plus 10 squared, right, because then I get that x times the 10 from the other side, and then the x from the other side times the 10 from this side. And when I do that, I'm going to get x squared plus 20x, right? So in order for me to have this plus 10 here, I have to have minus h. Well, h will have to equal -10 then, because negative minus negative will get me that positive, that x plus 10. So I know that my x value has to be -10. The only answer choice with that is B, so B will be my answer. All right, in the equation above, a is a positive constant, and the graph of the equation in the xy plane is a parabola. Which of the following is an equivalent form of the equation? All right, when I see this, I'm looking for the difference of perfect squares, right? I'm looking for an x plus a number, right? We'll call it a number. We'll just pick one, right? So we're looking for x plus a constant, right, times x minus a constant. And this isn't my answer choice. It's not A. It's not A. I'm just using this for demonstration purposes. And that gives me x squared minus a squared, right? Well, I know A is just A, right? So if I want this, what I'd actually have to do is I'd have to get the root of that, right? So if I want that, then I have to actually have x plus the square root of A minus the square root of A. Because when I do that, then I get x squared x squared minus my root A times my my root A times root A, right? Root A times root A is the same as root A squared. So then I get x squared minus A. So we can see our equation then will be x plus the square root of A times x minus the square root of A, right? Difference of perfect squares. All right, now we got question 31. A customer's monthly water bill was 75.74. Due to a rate increase, her monthly bill is now 79.86. To the nearest tenth of a percent, what percent did the amount of the customer's water bill increase? All right, to do this, we're going to use the equation new minus old over old. So our new bill is 79.86. We're going to subtract our old, which is 75.74, all over, and keep in mind this is times 100 to get the percent, right? Just remember that. All right, and this is all going to be over our old bill of 75.74. All right, so I'm going to plug that into my calculator. So I've got 79.86 minus 75.74, all divided by 75.74, and then I multiply by 100 to get my percent. And I see that when I round to the nearest tenth of a percent, I'm going to get 5.4%, because I get 5.44%, right? So 5.4 when I round down. All right, question 25. Some values of the linear function f are shown in the table above. What is the value of f of 3? All right, well, f of 3, don't get it mixed up. That 3 is talking about the x value, right? So we need the value of 3 of x, right? At 3 as x, and then we solve for f of x. So that's going to be the value of f of 3. All right, well, I see from 0 to 2, my run is 2, but I rise by 6, right? Because we go from -2 to 4, that's an increase of 6. So my slope's going to be 6 over 2, which is equal to 3. So 3x will be my slope. All right, so I got y equals 3x. All right, now I got to find my y-intercept, so that way I can. Actually, I don't even have to find my y-intercept, right? Because this is pretty easy. We see I'm just going from 2 to 3, which means my slope is 3, so I go from 4 plus 3. That's going to bring me to 7, right? So my answer choice will be B, and I don't even have to find the y-intercept because they were right next to each other. All right, question 26. A gear ratio RS is the ratio of the number of teeth of 2 connected gears. The ratio of the number of revolutions per minute of 2 gear wheels is SR. In the diagram below, gear A is turned by a motor. The turning of gear A causes gears B and C to turn as well. If gear A is rotated at a rate of 100 RPMs, what is the number of revolutions per minute for gear C? All right, well, if I know that I have 20 teeth in gear A and I have 60 teeth in gear B, then what I can say then is that since gear B is 3 times the number of teeth of gear A, then it will have 1/3 the RPMs of gear A, right? Times gear A's RPMs, which I'll just do GA RPMs, right? All right, well, gear A RPMs is 100, so we'll have 100 over 3 as our RPMs for B. And now we look at gear C, right? It has 10 teeth versus gear B's 60 teeth. Well, since it has 10 teeth, it has to have 6 times the RPMs of gear B, right? Since it has 1/6 the amount of teeth, it has to have 6 times RPMs of gear B. So we're going to multiply this right here by 6. We can go ahead and cancel this 3, call it a 1. We can call this 6 a 2, and we get 200 over 1, so our answer is C. All right, now we move on to question 27. In the xy plane, the graph of 2x squared minus 6x plus 2y squared plus 2y equals 45 is a circle. What is the radius of the circle? All right, well, we know the formula for a circle is going to be x minus h squared plus y minus k squared equals r squared. We see we have 2x squared and 2y squared, so we have to divide this whole equation by 2. When we do that, we will get x squared minus 3x plus y squared plus y is equal to 45 over 2. Okay, now here's what I'm going to do. I see I have x squared minus 3x. Well, to get that, I have to do x minus 1.5 squared. And here's why, because I have that negative 1.5 times an x right there, and then I'll have that other, this is when I FOIL, right? So pretend the squared isn't here, pretend that we have the other equation right here, right? And then I'll take that other negative 1.5, put it there, and I'll get that negative 3x. So that's how I know that I have this x minus 1.5 squared as that part. And then I look at my other part, and I have y, right? I got y squared plus 1y, right? That's a 1 there. It doesn't have to be there. You should just be able to recognize it. So we're going to have that plus y. And since we have that plus 1y, we know we have to have y plus 1/2 squared. So now what I have to do is I have to take this negative 1.5 squared, or take this negative 1.5, and I have to square it. So negative 1.5 squared is 2.25. And then I have to take this half right here, and I have to square that, right? 1/2 times 1/2 gives me 1/4, right, which is 0.25. So their sum is 2.5. I have to take that 2.5 right there, and I have to go add it to my r right here, right, my r squared. So when I add that 2.5 to this r squared, the first thing I'm going to do is I'm actually going to go ahead and put that 45 over 2 on my calculator. I see it's 22.5. I add 2.5 to that, and I get 25. Keep in mind that's not my answer, though. I need the square root of 25 because that is r squared, remember? So we need to square root that to get my radius. So the radius of the circle is root 25, which is 5. So my answer is going to be A. All right, question 28. 2 different points on a number line are both 3 units from the point with coordinate -4. The solution to which of the following equations gives the coordinates of both points? All right, well, the formula for this one, it's going to be absolute value of x minus our coordinate, right? So I'm going to put that as coordinates. So you remember this the next time that you have to take a test like this. It's going to be the absolute value of x minus the coordinate is equal to our difference, right? So our distance from that coordinate on the number line, which is 3. So I do that, I plug in my -4 for my coordinate, I get x minus -4. X minus -4 is x plus 4. So I get absolute value of x plus 4 equals 3. You can check that because you know that the distance 3 units from the point -4 is going to be -1 and -7. Plug in -1 plus 4 gives you 3, and -7 plus 4 will give you -3, which absolute value is 3, which means 3 equals 3. So you can check it like that as well. So A will be your answer there. Question 29. A motor powers a model car so that after starting from rest, the car travels s inches in t seconds, where s equals 16t times the square root of t. Which of the following gives the average speed of the car in inches per second over the first t seconds it starts? All right, well, we know our average speed, right? Our average speed, I'm just going to put that as s, is equal to our distance over time. We know our distance is s equals 16t times root t, right? We divide that by time because that's our distance. Our t's will cancel. And we know that our average speed then is going to equal 16 root t, which is B. All right, now we got question 30. The scatter plot below shows the amount of electric energy generated in millions of megawatt hours by nuclear sources over a 10-year period. Of the following equations, which best models the data in the scatter plot? Okay, right off the bat, I'm looking at my y-intercepts here. Right, I see that. I know that I have a positive, so I can get rid of A and B. Next up, I'm going to look at my two other terms, right? What I see is that I go up and then I drop back down. So I can't have both of them that are the same sign because we get a change at some point. So when I look at choice C, I see we have a positive times x squared and a positive times x. If that was the equation, it would just keep going up. It would never come down, right? It would just keep going up and keep going up. So I know C can't be my answer, and I know that D has to be my answer then. Okay, now I can function above models the height in feet of an object above ground t seconds after being launched straight up in the air. What does the number 72 represent in the function? I see there's no x by that, so that's going to be my y-intercept, right? So if t was 0, right, if t was 0, right, it's yet to launch, it's at a height of 72 then still, right, because h is my height. So I know that that's going to be my initial height before it launches or is dropped or whatever. So my initial height is going to be a, which will be the value of 72. All right, so question 25, it's referring to this up here. I'm going to read it. If x food calories is equivalent to k kilojoules of the following, which best represents the relationship between x and k? All right, I'm going to put x for there. I'm going to put k here so I know. All right, just looking at this, I see 4 times about 4 is 16. 9 times about 4 is 36, 37, right? And then 4 times just about 4 will give me, once again, that 16, right? So I know that my k then is going to equal about 4 times whatever my x is. I just find the answer choice that says that. I see that I have that in B. K equals 4.2 times x, right? And that makes sense because 4.2 times 4 is going to give me 16.8, right? Which is shown here. That's just about 16.7, close enough. So my answer is going to be B. All right, question 26. Did I get all those up here? Let's just double check. Looks like I did. All right, question 26. If the 180 food calories in a granola bar come entirely from P grams of protein, F grams of fat, and C grams of carbohydrate, which of the following expresses F in terms of P and C? All right, so I'm solving for F. Well, I was told up here that of fat per 1 gram, right? So for 1 gram of fat, I get 9 calories, so it's going to be 9F, and then I'm going to have 4 calories per gram of protein and 4 calories per carbohydrate. So my equation then is that 180 calories total is going to be equal to that 9 times every gram of fat plus that 4 times every gram of protein plus that 4 times every gram of carbohydrates. I got to solve for F, so I'm going to subtract 4P and I'm going to subtract 4C from each side, get rid of all of that. Subtract 4P, I subtract 4C, so now I've got 180 minus 4P minus 4C. That's going to equal 9F, so I divide each side by 9 to isolate F. So this is all going to be divided by 9. 180 over 9 is going to give me 20. And then I'm going to have 20 minus 4/9 P, right? So I just find which one has that. So I can go ahead and see they all have 20. I see this one, there's a plus sign, and this is also plus, so that's wrong. I see I have a plus here, and this is also plus. That would give me plus 4/9 P, but I need minus, so I can get rid of that. I see these two each have minus, and then I know I also have minus 4/9 C. Well, the problem is when I look at answer choice C right here, I have negative 4/9 times negative C. That's going to give me plus 4/9 C. So I know that that's wrong, and I know my answer is going to be B, because then I have minus 4/9 P and also minus 4/9 C. All right, question 27. The world's population has grown at an average rate of 1.9% per year since 1945. There were approximately 4 billion people in the world in 1975. Which of the following functions represents the world's population in billions of people T years since 1975? All right, well, this is exponential growth, right? This isn't linear, so I can get rid of anything with linear, and it has to be exponential because each year as we add more people, we're increasing 1.9% on top of what it was the year prior. So I start with 4 billion, and I'm multiplying then by 1.019, because that's what 1.9% is. I see that answer choice B doesn't have that. I know my answer is going to be A, and I multiply that by T years from 1975. All right, now I move on to question 28. In the xy plane above, a point not shown with coordinates st lies on the graph of the linear function f. If s and t are positive integers, what is the ratio of t to s? All right, so positive integers, I'm looking right here then. I see my y-intercept is 0, so I know that my point st, that's xy, right? So xy, and since it's linear, it doesn't really matter what point we pick, and since there's y-intercept 0. So I'm asked, what is the ratio of t to s? All right, well, if my x is my s, and my t is my y, right? So I'll go ahead and put that right here, xy. Now I've got to flip them, right, to find this ratio here, this t to s. Well, t to s then will be my y to my x. Right, that's a 2, y to x. This is going to be my ratio. So I look here, I see my y is 6, and I see that my x then is 3. So it's going to be 6 over 3, 6 over 3, that's equivalent to 2 to 1, so my answer is going to be choice C. Right, and I'm just going to quick double check that. ST, we'll say S is 3, we'll say T is 6. Now I need T to S, that's going to be 6 to 3. 6 to 3 is the same as 2 to 1, answer is going to be C. Alright, 29, a circle in the xy plane has equation x plus 3 squared plus y minus 1 squared equals 25. Which of the following points doesn't lie in the circle? You can plug all these in, that's going to take you a bit longer, so what I'm going to do is I'm going to find my center. So I know my standard equation for my circle is going to be x minus h squared plus y, that's a plus there, plus y minus k squared, where my centers, there's not plural centers, right, is hk, and that's going to equal my radius squared, so I know my radius is 20, I know my radius squared is 25, so I'm going to go ahead and divide, or not divide, I'm sorry, square root 25 to get my radius, right, so I get 5 as my radius. I see that my center then, since I have plus 3, and it's supposed to be x minus h, I know that h has to be negative 3 then. Alright, so I know h is negative 3, and then I know that k, right, it's already in minus, so I know my k is 1. So my center is going to be negative 3 and 1. Alright, so if I look at B, that's my center, right, that's obviously going to be inside my circle. And then I look at 0, 0, well, 0, 0, that's over 3, right, so it's over 3, and it's also down 1, right, so I got 3 squared, and then it's going to have, it doesn't matter if it's plus or negative, right, because it's squared. It's going to be 9 plus 1, that's going to give me 10, right, 9 plus 1 gives me 10, and now when I root 10, I know that root 10 is going to be less than that radius of 5, right? So since it's less than that radius of 5, I know it's in my circle still, so I know that 0, 0 is in my circle. Alright, so now I'm looking at negative 7, 3, and I'm looking at 3 and 2. Well, right off the bat, when I see 3, 2, I know that I had negative 3 as my x center, right? Well, 3, that's 6 away, right? And my radius is only 5, so I can't reach 6 away to get there. So I know, therefore, that my answer has to be D. It can't be inside the circle. Now I look at question 30. The manager of an online news service received the report above on the number of subscriptions sold by the service. The manager estimated that the percent increase from 2012 to 2013 would be double the percent increase from 2013 to 2014. All right, well, what that just means right there is that in 2013 to 2014, they had half the percent increase they did from 2012 to 2013. How many subscriptions did the manager expect would be sold in 2014? All right, well, our percent change from 2012 to 2013, we're going to use the equation new minus old over old. So our new is going to be that 5880, and our old is 5600, and that's all over our old of 5600. And then when we multiply 100, that'll give us our percent. So we take that, I see I've got 280 up top over 5600. I'm going to plug that into my calculator. 280 over 5600, and I get 0.05. I multiply by 100, I know that's 5%. All right, so we got 5% right here. That's our 5% increase. Now we know that that increase there is double what we're going to get in 2013 to 2014. So when we divide it by 2, that's going to give us our new increase, right? So now we know we increased by 2.5% from this 2013 to our 2014. So we're going to increase by 2.5%, which is the same as multiplying by 1.025. So we take that 5880 and we multiply it by 1.025, and we're going to get 6027, which is answer choice B. All right, now we can go ahead and move on to the written portion. For the finale of a TV show, the viewers could use either social media or text message vote for their favorite of 2 contestants. The contestant receiving more than half the vote won. An estimated 10% of viewers voted. 30% of the votes were cast on social media. Contestant 2 earned 70% of the votes cast using social media and 40% of the votes cast using text message. Based on this information, which conclusion is accurate? If all viewers had voted, contestant 2 would have won. Alright, well, we're told the contestant receiving more than half the vote won. We're told an estimated 10% of the viewers voted. 30% were cast on social media. Contestant 2 earned 70% of the votes cast on social media, and 40% of the votes cast using a text message. Okay, we don't know how many people voted by text or by social media though, so we can't say that contestant 2, or A, if all viewers had voted, contestant 2 would have won. We don't know that, right? We can't make a statement on if all viewers had voted because we don't know what all viewers thought. And then B, viewers voting by social media were likely to be younger. It doesn't say that, and even though that may, like in the US, like potentially be true, we're not told that, so we can't make a conclusion on that. See if all viewers who had voted by social media instead of by text message, contestant 2 would have won. No, because the means by which you voted does not affect who you voted for. And D, viewers voting by social media were more likely to prefer contestant 2 than viewers voting by text message. This is true because 70% of the votes that contestant 2 earned were from social media and only 40% of her votes were from text message. All right, question 25, population of Greenleaf, Idaho. The table above shows the population of Greenleaf, Idaho for the years 2000 and 2010. If the relationship between population and year is linear, which of the following functions P models the population of Greenleaf T years after 2000? All right, well, I see I went down in population by 862 minus 846, which gives me 16. And I see as I went down in population, my time increased by 10 years. So I went down negative 16 over 10 per year, which is equal to negative 1.6 T. I know I start in 2000 with 862 people, so my equation therefore will be P of T is equal to 862 minus that 1.6 T. All right, so my answer is A. All right, question 26. To determine the mean number of children per household in a community, Tabitha surveyed 20 families at a playground. For the 20 families surveyed, the mean number of children per household was 2.4. Which of the following statements must be true? Well, it's at a playground, first of all, right? So we know that that's a biased sample, okay? Because you can't take a survey of the amount of people in a family at a playground because it's likely going to be higher than the mean of the general population. So the mean number of children per household in the community is 2.4. No, because we have a biased sample. A determination about the mean number of children per household in the community should not be made because the sample size is too small. While 20 is a decently small sample size, it's considered large enough. So we're not going to pick that. And then C, the sampling method is flawed and may produce a biased estimate of the mean number of children per household in the community. Yes, it's flawed because it's taken at a playground where the people who have families go, right? Larger families are more likely to go to a playground. D, the sampling method is not flawed, it is. So answer C there. 27, in the xy plane, the point PR lies on the line with equation y equals x plus b, where b is a constant. The point with coordinates 2p, 5r lies on the line y equals 2x plus b. If p can't equal 0, what's the value of r over p? All right, so what we're going to do is we're going to plug in our points 2p and 5r into this equation right here where my arrow is pointing. So we're going to have 5r then equals 2x. We're told that x will equal 2p, so 2 times 2p will give me 4p, 4p plus b. I'm going to go ahead and solve for what b is going to equal, and then I'm going to plug it into my equation up top. All right, so that means b then will equal 5r minus 4p after I subtract 4p from each side. So I'm going to plug that in to my equation y equals x plus b with my points pr. All right, well, r is going to be my y value. So r will be y, and that's going to equal p, our x value, plus b. We're told b is 5r minus 4p. Okay, so p minus 4p is going to give me negative 3p. And then when I go ahead and subtract 5r from each side, I get negative 4r equals negative 3p. Now I need to get r over p. So what I'm going to do is I'm going to go ahead and I'm going to divide my right and left sides by p. So I have negative 4r over p. And now I'm going to divide each side by negative 4, right? So now I get r over p equals negative 3 over negative 4. Negative 3 over negative 4 is equal to 3 over 4. My answer will be B. All right, question 28. The 22 students in a health class conducted an experiment in which they recorded their pulse rates and beats per minute before and after completing a light exercise routine. The dot plots below display the results. All right, let S1 and R1 be the standard deviation and range, respectively, of the data before exercise. Let S2 and R2 be the standard deviation and range, respectively, of the data after exercise. Which of the following is true? All right, well, I got my range. I'm going to go ahead and do that first. Okay, range is going to be my maximum value minus my minimum value. My maximum is 88. 88 minus 56 gives me 32 is my range 1. All right, my range 2 is going to be my maximum value minus my minimum value. 112 minus 80 is also 32. So I see my ranges are equal. I can get rid of any answer choice without those. And now I'm left with A and D. So I'm talking about my standard deviations. I'm told, are they equal or are they not equal? All right, standard deviation is basically the square of each value from the mean, right? So I see that these values here in my first set before exercise are very concentrated around their mean, but I see down here they are much more dispersed from their mean, right? So the square of their values from their mean is going to be much higher. So the standard deviations of the two are not going to equal each other. So my answer is going to be D. Those two standard deviations are going to be very, very different values, but also R1 equals R2. So my answer is D there. All right, question 29. A photocopy machine is initially loaded with 5,000 sheets of paper. The machine starts a large job and copies at a constant rate. After 20 minutes, it has used 30% of the paper. Which of the following equations models the number of sheets of paper P remaining in the machine M minutes after the machine started printing? All right, well, we know that we start with 5,000 sheets, and we know after 20 minutes we use 30% of the paper, right? So that's going to be a decrease of that 30%, 0.3, times our 5,000. And now we have to set that over each minute it took, which is 20 minutes. And that's going to give us our slope. So now I'm going to go ahead and plug that into my calculator. I see I have 0.3, negative 0.3 times 5,000. And that's going to give me negative 1,500 over 20, which would give me negative 75 is my slope. I'm there just so you know it's slope, negative 75. I know that this is not going to be an exponential function, right? So I can go ahead and get rid of C of D off the bat anyways. And now I see I have 5,000 minus 75m as my answer B. All right, I'm going to erase this just so I don't do anything on it with the next problem, 30. The complete graph of the function f and a table of values for the function g are shown above. The maximum value of f is k. What is the value of g of k? All right, well, the maximum value of f I see is going to be right here. Okay, so the maximum value of f is 3. So I plug in 3 then into my equation on the right for g of x. So I plug in 3 for x, right? G of k means I'm putting in 3 for x. I put in 3 for x, and I see I get 6. So my answer there is going to be B. All right, now I move on to question 31. We're on the free response now. Question 24, if f of x equals 5 times x squared minus 3 and f of x plus a equals 5x squared plus 30x plus 42, what's the value of a? Okay, so what I see here off the bat, I see my big difference is I have plus 30x, but I have no x value here. So what I'm looking at is I need to have a 5 times x plus a. We don't know what a is yet, right? Squared minus 3, and that's going to equal our other equation, right? So I look at this, I see I have plus a. So I need to solve for a. All right, well, I see I have plus 30x in this equation. So I know that when I do this, right, when I square this, when I do x plus a times x plus a, I know I'm going to get my a times x right here. And I'm also going to get a times x here. So I know that I'm going to get 2 times a x. So 2 times whatever a is times x, but I also know I have this 5 that drops down, right? So I have this 5 times 2 times ax. I combine that and I get 10ax. Well, I know that that has to equal 30x, therefore I divide each side by 10. 30 over 10 is 3. I get 3x equals ax. I divide each side by x, and I see that a is equal to 3. So my answer there is going to be C. Okay, now I can move on to question 25. 25, if sine of x is equal to a, well, which of the following must be true for all values of x? All right, when I see this question, I see my answer choices. The first thing I'm thinking is the sine of x equals a. Well, then that means that the cosine of 90 minus x, right, which is the other angle in that right triangle, will also have to equal a. So I know that my answer is going to be C, and that is a relationship that you should really try to memorize for the SAT. All right, moving on, I've got question 26. h of x equals negative 16x squared plus 100x plus 10. Quadratic function above models the height above the ground h in feet of the projectile 8 seconds after it had been launched vertically. If y equals h of x is graphed in the xy plane, which of the following represents the real meaning of the positive x-intercept of the graph? All right, the positive x-intercept of the graph is where the height is 0. Okay, so after it's launched, when it falls back to 0, that's our positive x-intercept. So that is the time at which the projectile not reaches its maximum height, but the time at which it hits the ground, right? The height is 0 at that point. So our answer is D. Question 27. In the xy plane, the graph of the polynomial function f crosses the x-axis at exactly 2 points, a of 0 and b of 0, where a and b are both positive. That's important. Which of the following could define f? All right, well, if both my zeros are positive, I know here in this equation, my 0 will be a and my 0 will be b, right? I got to flip the sign, right? So I have this is negative, which means x will equal positive b, and I have x minus a, which means that x will equal positive a. I see those are both positive zeros, so my answer will be a. Question 28, if y equals 3x squared plus 6x plus 2 is graphed in the xy plane, which of the following characteristics of the graph is displayed as constant or coefficient in the equation? Right off the bat, I'm thinking y-intercept, right? If I put in 0 for my x, that's going to be 0. I put in 0 for my x here, that's going to be 0. And I see my y-intercept then is going to be 2. So my answer is going to be C. Question 29. We've got minimum wage on our y-axis, years since 1940 x-axis. The scatter plot above shows the federal mandated mandated minimum wage every 10 years between 1940 and 2010. A line of best fit is shown, and its equation is y equals 0.096x minus 0.488. What does the line of best fit predict about the increase in the minimum wage over the 70-year period? All right, each year between 1940 and 2010, the average increase in minimum wage was $0.096. Yes, that is going to be our answer. And I'm going to show you why the other ones are false real quick here. Each year between 1940 and 2010, the average increase in minimum wage was almost $0.50. Well, in that case, the minimum wage would have gone up about $35. The graph doesn't show that. It shows that it's gone up about 6 from 1940 to 2010. See, every 10 years between 1940 and 2010, the average increase in minimum wage was $0.096. Here's why this is wrong. This every 10 years messes it up. Because if we think about it then, 70 years later, that would just be that 0.096 times 7, which would only be about 70 cents, right? And that's not how much it increased. It increased by more like $7 or $6, right? So that one's wrong. And then right here, every 10 years between 1940 and 1910, the average increase in the minimum wage was $0.488. No, that's not what the line of best fit is saying at all, right? Because once again, you know, in that case, we put in 7 because 70 years, right? Multiply it by that, and you're still only seeing an increase of $3.50. That's not what it shows, right? A is what it shows, so answer is A. Okay, are we on 30? We are on 30. Okay, ice cream sales versus temperature. The scatter plot above shows a company's ice cream sales, D in dollars, and the high temperature T in degrees Celsius on 12 different days. A line of best fit for the data is also shown. Which of the following could be an equation of the line of best fit? All right, so this one, first thing I'm going to do is I'm going to find the slope. So I'm going to pick a point here, and I'm going to pick a point farther away because there aren't any that really intersect real well with my y-axis. So I'll pick this one because why not? So we'll go ahead and trace it over. We see we got 800 there, 500 here. So we rose by 300. So our rise is 300. How much did we run? We went from 12 to 22. That's a difference of 10. So we see that's going to be roughly 30, right? Our slope will be roughly 30. Closest thing to that's going to be 33. I'll take it. So now one thing to note, this isn't 0 here, right? This is 10. So if we were to keep going back, 0 is going to be more like right here. And if we kept going down, right, we also have 300 here and not 0. So if we were to keep going down, right, we see that our y-intercept is not going to be anywhere near 300, right? It's just going to keep dropping, and then by the time that we get to that 0, it's going to be more between 0 and 100. So I know my answer is going to have to be D, and I can plug in a point and quick check it, right? Let's say I put in 12, because why not? We put in 12 for T, 12 times, we'll just use 30 because it's easier. 12 times 30 is going to give me 12 times 30 should give me 360 plus 84, right? It's going to give me right around this range. So that's going to be good enough. Answer is going to be D. All right, question 31.